Hello, good afternoon. Thank you for being back with us for second day of conference. I remind you that you can ask your question if you follow via Zoom by the Q&A button, and if you follow us via YouTube on the IRC channel, on which details are shared on the page. It's #PTS21 on Libera.chat. We start the afternoon with Timothée Ravier, who will present Fedora CoreOS, which is a container-focused OS to securely deploy and run applications. Timothée is a Linux system and security engineer working at Red Hat as a CoreOS engineer. Timothée, it's your turn.
All right. Good. All right. Hey. Hi, everyone. So yeah, let's talk about Fedora CoreOS. So we'll talk about these topics from different angles. So the first one, the thing we'll give a short overview of what Fedora CoreOS actually is and how it works, where it came from. And then we'll see what makes it great to actually run containers on Fedora CoreOS. And finally, I will do some demos. So single node, the Nomad is a container orchestrator, and Kubernetes. So you can see that you've got multiple options to use Fedora CoreOS if you want to run applications. All right, so what's Fedora CoreOS? So let's dig a little bit into the history first. So Fedora CoreOS is currently an emerging Fedora edition. It came from the merging of two communities. The first one is CoreOS Container Linux OS communities, and the second one is Project Atomic Host. Two of those projects had very specific design choices and benefits, and we took the best of them both to build Fedora CoreOS. So essentially, we incorporated all the philosophy behind Container Linux, the way the stack is provisioned, and the way Container Linux was very first cloud native and very aware of how the cloud works. And from Fedora, from Project Atomic Host, we took the Fedora Foundation, the way the update stack works, how we update the system, and finally, the SLNX enhanced security. All right, so what's the philosophy, in sense, behind Fedora CoreOS? Well, the main idea is that we have automatic updates that require no interaction at all for administrator. So if you just leave your node running, by default, you will get automatic updates. Then the second most important point here is that we also have a strong focus on automated provisioning. So the idea is that all your nodes in your system, in your cluster, in your cloud start approximately from the same point, and then you use a config file to automate how it is provisioned or it is configured, which application to deploy it and on it, and things like that. Everything here happens on first boot via a program called Ignition. And those two main mechanisms enable us to do the third part, which is building an immutable infrastructure. So immutable infrastructure does not mean that you cannot change it or that you do not change it, but it means that you control how it gets changed. So instead of having half-dated systems or half-dated applications, something like that, you move from one version to the other in an atomic fashion, and you control all the change gets released onto your cluster, onto your applications. The goal behind it is once you've automated all the deployment and the system configuration, then you can do that properly and actually have a full view of what you deploy of your cluster. The main thing, one of the main principles behind the immutable infrastructure concept is that you can, if you move all the way to it, you can even re-provision your node when you want to perform updates. Essentially, instead of having in place updates, you simply re-provision on the new version directly, and you get from there, you update your whole cluster. All of this is actually possible because we run all the users' software in containers. So this separation between the host with the system and the containers, which run the software, your applications, is what makes the updates reliable. All right, so Fedora CoreOS itself is supported on all the major cloud platforms. You can see a list here. I won't name all of them. You can even directly launch Fedora CoreOS instances on AWS and GCP. And of course, it's still we still have support for bare metal instances. So if you want to run Fedora CoreOS on bare metal servers, it's perfectly supported. What I forgot to add in this slide is that Fedora CoreOS is currently x86 only, but Arch64 is coming. Okay, so we're here at Pass the Salt. You're not here to hear me talking about Fedora CoreOS, just Fedora CoreOS. It's about, okay, security. What makes actually Fedora CoreOS interesting for security purposes? And what do we actually do to make all of that secure and work securely for you? Well, the thing is, we did a lot of things in different phases, and I will give them details to you here. Shocking news: software has bugs. All right, so that's like no news here. We have a lot of bugs. Most of the bugs are memory safety issues. Then you get all the logic bugs and everything. When you're running a Linux system, essentially, well, you get all the Linux vulnerabilities too. That potentially there are a ton of them. If you look at all the syscalls, the sysfuzzer, the sysbot fuzzer from Google that is running permanently, you get tons of bugs, potentially crashes for the kernel, so potentially a lot of vulnerabilities. So yeah, some of those bugs are CVEs, some of those don't have CVEs, so you cannot really rely on those. Well, and everything else. So yeah, bugs. We have plenty of them. That's not an issue. We always have bugs for now. And the solution is not like, in short term, we don't have a real solution. So we have to do things to make sure that all those bugs get contained somewhere in some way, and then we can manage that. And that's the goal here. So the first thing we do is to reduce the OS footprint. So if you want to have less bugs, then you get less software. And that's the basics here. The first step, we remove as many software as possible. So in Fedora CoreOS, essentially, we only ship the essential packages in the essential tools that you need as an administrator. So we're built from Fedora, so we track Fedora Linux packages, and you get all the benefits that get with that, so CV tracking and things like that. But essentially, we are following the update cycle of Fedora itself with a small set of packages and container runtimes. So obviously, if you want to run your software applications inside containers, you need container runtimes. The last part is we only ship one single interpreter, which is Bash. We don't ship Python, we don't ship Perl or Ruby or something else. We only ship Bash because if you want to have an interactive shell, you need Bash, but essentially that's it. We don't really recommend you writing all your management in Bash or all your software in Bash. Okay, so the next step is, okay, I want less software, then I want the software that actually is on my system to be safe. And that's what we've done with Fedora CoreOS. So the goal is we try to use as much as possible safer languages to build the software. And we mostly use almost memory safe, all memory safe languages, which are Go and Rust here. For most of our programs, and with different contexts. It depends on the context which one is used. And yeah, and we try to make very sure that all of the software we include on top of the additional ones that already exist is written in memory safe languages. So here, like, yeah, the most important one, like the container engines are mostly written in Go, and all the updates and system management software, so RPM History and Linkade, are written in Rust or in progress of being rewritten in Rust. All right, so now we've got safe languages, we reduce the OS footprint, and all right, then how is actually the system laid out? Well, we try to, in Fedora CoreOS, the system, the system is laid out a little bit differently from classic OS systems. So the system itself is managed by RPM History, which is a tool to manage and update the system. Essentially, we call it an hybrid image package system. So the idea is that it's a little bit like Git for your operating system. So instead of moving one package after the other when you do an update, for example, you essentially move from one version to another, just like you would do with an image, full image of your system, like for example on Android or on an embedded system. So the same way, like with Git, you get commit hashes for all your changes, all your commits on your system. Here you get commits for every single deployment, every single version that you want to run of Fedora CoreOS on your system. So here I've put an example. So it's another one, 32 with the date and the specifier. And essentially every single version has a full hash. So this is a short hash, but you get the full SHA to 256 hash. All the changes that comes with that benefit from using images and moving from one version atomically is that we can actually have most of the system read only at runtime at all times. So you get /user read only all of the time. /boot is also read only. And only the partitions that are actually used to write data, like /var and /etc for storing configuration, are read-write at runtime. And everything else is managed by the system. So this by itself isn't like a full security protection, because if you're root, you can still remount, read-write, and change things, but it certainly prevents accidents or misconfigurations. And it provides a clear distinction between where you store your data, where the system stores its data, and where you actually want your configuration to be. So with all that said, we also have automatic updates by default. So when you boot up a Fedora CoreOS node, you get automatic updates. So if there's a new version, it will update and reboot into the new version. And approximately 2 weeks, you get new versions. So yeah. If you have automatic updates, we want them to be as reliable as possible. And that's what we're trying to do here. As the software, most of the software runs in containers, usually we have a clear separation of concern between the hosts and the software running in containers. And to make all that work, we run a lot of tests. We have a really full, really big test suite that we run for every single version of the system that we build and every single PR, and we test every single code that gets added to the system. This enables us to make sure that when we release a version, we're really confident that it's going to work. On top of that, we also have multiple update streams, what we call update streams. It's like channels where you can get the next version, the upcoming version of Fedora CoreOS a little bit before the first one. So the idea is that you can get you can try it before it gets put into the stable. So this is coming just right off the way. So you control how your system gets updated, and if for something, for whatever reason we miss something, you still find a bug in a specific program, you can always roll back. So that's the benefit of being an image-based system, is that at all time on your system, you always have the version you've booted into and the previous version you had. So if for whatever reason you have a bug, you can always roll back, reboot and roll back to the previous version. So what does it look like the update streams? The idea is that when we build the systems, we have three main streams, with all of them with automatic updates. The first one is called the next stream, which is essentially what's coming next in Fedora CoreOS. And usually it gets activated and it gets changes when we prepare for the next version of Fedora. So for example, right now we are on Fedora 34. And when we will be moving to Fedora 35, we will enable the next builds, the next update stream with the changes for Fedora 35. Then you've got the testing stream. So it's a little bit further down the stream, and it's essentially all the fresh packages from Fedora. So you get everything that is the latest version that has just been put out in Fedora, which should be stable. But just for safety, we put that in testing to make sure that nothing's broken for the Fedora CoreOS use cases. We essentially create testing snapshots every 2 weeks. And then they get put into stable. So when we've done enough testing on testing releases, we move them to stable. And when stable gets deployed, if you run the system with stable, you get all the changes from the last 2 weeks from the testing release. So the goal is to have releases every 2 weeks, and all the streams are here to help us find issues before they hit stable for the stable users. So how does it go exactly? Well, so we have like a defined naming scheme for which all the version can be read and which fields correspond to what. Essentially, it's to help us read like the version which version corresponds to which testing stream and everything. And every 2 weeks we cut out the testing release. We wait 2 weeks. We try to find bugs in it, and if there are any blocky bugs, then we move on and we promote that to stable. All right, so yes, we have the system. The system itself is managed by IBM S3, and then you get everything else inside containers. So on Fedora CoreOS, we have 2 main container runtimes available. You can only use one at a time, but you have the choice between the 2. So the first one is Podman. It's a daemon-less container engine, which was both rootless and rootful containers, and Moby engine, usually called Docker, which has a central daemon, 2 central daemons to manage containers. And for both of those container engines, the main point is that they are confined with SRNX. So all containers that run on the system are confined with SRNX. Yeah, even the system services actually, because we use the targeted policy from SRNX. So most of the system services are confined into their own domain with SRNX, so restricted to only the set of permissions that they should be able to do. And every single containers by itself is confined and cannot talk by default to any other container. And so this protects every single container from the other, and this also protects the host from containers. If you have an application that gets hacked and which tries to poke on the host and try and change things on the host, it will get blocked by SRNX. And usually when you hear about SRNX, it's about, oh, okay, that's great, whatever. Does it actually work? Yeah, well, yes. Like the 2 major vulnerabilities in RunC that were found in the last 2 years were blocked by SRNX. So essentially, it's not just like a theory. It's really in practice working and blocking real vulnerabilities. So the links here are to the CVEs and the details. And they are focused on OpenShift, which is a rather version of Kubernetes, but they work exactly the same, and they have the same impact and same blocking power in Fedora CoreOS. All right, so with that, we also have automated provisioning. So the idea with Fedora CoreOS, as I've said in the beginning, the idea is that you want all your nodes to look a little bit like the same and start from the same point and be automatically provisioned on first boot for the configuration that you want to use for your system and deploying applications. And to make that happen on Fedora CoreOS, we use Ignition to automate the provisioning. So the idea is that all the logic of all the machine lifetime, everything that gets installed, configured, is encoded into the config. And if you want to reprovision a node, create a new node, add nodes to your cluster, you can always add them because you will essentially use the same config or with slight variations, and you deploy the node because everything is there. As all the nodes start from the same point, we also use the same configs on cloud platforms and on bare metal, which is very interesting because you could have an hybrid cluster. So for example, you can have half your nodes inside your company on bare metal clusters and half your nodes on another cloud providers remotely in another region, for example, even either for availability or for backups or whatever. Yeah, so it's the same configs everywhere, the same mushrooms. You don't have to use multiple programs and multiple configuration variables to get that working. So what Ignition configs essentially the declarative JSON documents that gives you that where you can tell Ignition how to configure your system on first boot to make that work. The idea is that they run only once. In the difference of some other configuration management systems, Ignition runs only once and at first boot during the initial manifest, so you can actually do a lot of changes. You can write files to system, and you can even reprovision completely your node. You can set up full RAID on if you have multiple disks. You can change the file systems. You can change a lot of things because essentially you have all the power. You're running fully in RAM, and you get all the power to customize things on the disk before you start your system. If for whatever reasons the configs are bad or something happens or the disk fails, you don't get the half provision node. You don't get a node at all. So it either works or it don't, which gives us a very strong perspective, because if your system does not come up, you know there's a problem, and you're sure that if it does come up, nothing failed, and the configuration itself has been correctly applied. So yeah, JSON's Ignition configs are JSON documents. So if you take a look on the right here, you get a short example of what an Ignition config would look like. And well, it's JSON. It's readable, but it's not great to write. So the idea is that we don't write Ignition configs directly. We leave that to the system, to machines. And instead we write butane configs, which are nice YAML formatted documents that essentially gets translated into Ignition configs via a compiler, a butane compiler. Yeah, and for example, you can see on the right the similar butane configs for a similar config where the format is very, very close to the Ignition format, but as it's YAML, it's a little bit easier to write and understand. You get almost the same semantics. You get some sugar, so some properties are converted into longer forms configs into the Ignition version from the butane configs. And the last most important point is that when you write butane configs, the main benefit you get from it is that the butane transpiler tries very hard to validate config first before you even boot your system. So if you write something that is broken, that has no chance to work, then it will tell you. All right. So that's the main thing about Fedora CoreOS, and the main thing we do to make all of this work and securely run containers on top of Fedora CoreOS. And now I'll show you 3 use cases, because an OS is great. We build a great OS with those things. It has a lot of functionality. We work really hard to make it secure, but if you can actually run things on top of it, then it's meaningless. And that's the main thing we want to do here as users, as sysadmin developers. We want to run our applications on top of a secure OS, on top of a solid foundation. And that's what we're trying to, what I'll try to do here is showcase to you here. So the first demo is about running a matrix server. So if you've never heard about matrix, essentially it's like it's IRC, the new IRC in sense. It's a protocol for communication between, for instant communication, and it has a lot of nice properties, like you can self-host it. It's fully open source. You can self-host, and you get full cryptography protection. So you get encryption, authenticity, you get whole history and things like that you don't get on IRC by default. So yeah, so the first thing I'll show here is a config that I've written that will help you, that essentially helps deploying a single node, a single Fedora CoreOS node, where you get all of the software needed to run a matrix server, your home matrix home server, we call it home server in the matrix terminology, to self-host all that on a system software. So the idea is that you get on the server here, you have several moving parts. So we'll run all the software inside containers, of course. So which is Podman. We will know that with Podman, and you've got several elements. So the Synapse program is the main Matrix on server. It is a PostgreSQL database, and to work and on the same system alongside, we'll also run the web version of the client for Matrix, so you can actually use it to interact with the system. Yeah, so the config itself is the most interesting part, because this is what gets you a node with everything configured here, and I'll go and show you that now. So config here, let's stop sharing. Switching. Okay. Oops. All right. So here's the config. So the repo here, everything will be linked to the slides that we'll share right after. And essentially the config here is a repo, and everything is here. Everything is stored here, and you get everything needed to deploy a server. So all of the applications are running inside containers. So they are managed by systemd here and systemd units, which are listed there. So it's a big pool of text. So I don't expect you to read everything. It's just talking a little bit about the layout. So you've got every single application as a systemd service unit by itself, which runs an application inside a container. And then we deploy some files, some configuration files. So at the end here, we have a lot of various folders, for example, and files we put there with either default values or secrets, for example, that we store on the server and that we want to have deployed on first boot. So what I actually did is I deployed one instance of that config on GCP right now in a virtual machine, and it's available right there. So if you go on chat.fedora, chat.fcos.fr, I've deployed an instance here, and it's open registration, so it will get destroyed in about half an hour. So don't rely on that for you on your account, but you can actually try it and sign in. And so I've got an account here. If I just remember the password again. Yeah, let's skip the security, and there we go. And yeah, that's mostly it. If you want to give it a try and give it, oops, this is a bit small, sorry. And yeah, it's essentially a matrix on server with a client running. So if we take a quick look, yeah, I don't have much time, so I will take a quick look. Yeah, I don't have much more. So the second demo is about running Nomad, which is a container orchestrator on top of Fedora CoreOS. And I've written an example here, configuration, the same, which helps you deploy Nomad, which is essentially running a three server and 3 client system on top of Fedora CoreOS, and everything is configured here, and you get all the deployment for you. So yeah, the configs are in this repo here. And if I go, for example, and yeah, I won't actually have the full time to show you that, so I won't be able to do that. I've deployed it, but yeah, should I? So yeah, that's Nomad. If you've never heard about Nomad before, it's a way to orchestrate your applications across multiple nodes. And finally, the third option that I wanted to show is how to use another example to use Fedora CoreOS is you can also run Kubernetes distribution on top of Fedora CoreOS. So you have multiple options. One of those is to use Typhoon. So which is a distribution that uses Fedora CoreOS to run Kubernetes on multiple clouds. And you can also run OKD, which is the upstream version of OpenShift. So why can't I switch tabs here? Okay. Already, which is upstream version of OpenShift, which also runs on top of Fedora CoreOS, which is what I've deployed here. So I've deployed a sample instance of OKD, a cluster here. I've got a couple of nodes. I've got 6 nodes. And if we go and take a look, for example, at one of the node here, and we log into the node as I'm an administrator on the platform. Yeah. And if I just get out of the debug bug, we are actually running Fedora CoreOS on top, actually running on top of Fedora CoreOS. And so if you've never seen this before, this is the web console for the OpenShift or OKD clusters, where you can deploy your applications, you can deploy new containers, and a lot of things get configured. So from the main difference between the initial configs and this one is that you get a lot of things. You get certificates, you get management, you get auto updates. You can move your cluster from one version to the other automatically and things like that. All right, and that's like the top use cases that we have for Fedora CoreOS, where you can run your containers securely, because everything we do for Fedora CoreOS gets when you build your applications on top of those things, you get all the benefits from the base we work on. Switching back. And I'm good if there are any questions.
Thank you very much. So please write your questions on the Q&A. Otherwise, Mathieu, you had some, I think.
Yeah, I had some questions about the use of SE Linux. I was wondering if the contain processes run with the same SE Linux context, or is it or do you have policies that are loaded inside the containers, or regarding what's inside the container?
Yeah, so that's a good question. Right now we have a single context, a single domain for all containers, and then we use categories, so SNX categories, to separate them between them. So essentially, they get all the same set of permissions. They get all by default network access and things like that, and then the categories itself separate them from one another and from the host system. So yeah, we don't load specific policies for each containers yet. That's a feature potentially coming later.
Yeah, and have you explored the possibilities to maybe have a system to enable the containers to load their own policies? I was thinking about something like landlock, but I don't know if this would be easily applicable to this use cases.
So that could be an option. The main thing here is that we probably don't want to load arbitrary policy from containers, from untrusted containers, because when you had, well, essentially an untrusted container could add if you loaded a policy, it could add any roles into the SNX policy and change things on the host, which would be not great. So we would either need a way to validate the policy beforehand, before we inject it to the kernel, or have something else like clear concerns of separation between the container policies and the system policies, which does not exist right now. So it's all a single policy.
Or maybe something like a policy namespace, or
yeah, it could be. It could be. There's work on that. I don't know how much has progressed on the Linux fronts.
Okay, thank you.
There is a question from Xavier in the Q&A. If you can see it, otherwise you can read it out.
Yeah. So the care is not to mess up with local firewall rules. All CoreOS handles this in a specific tool. So essentially, we don't. It's there is no firewall configured by default, and you get to pick up your own and write your own. So you got all the basics, IP tables and NF tables rules, tools available to write a firewall. Otherwise, you either do it yourself or write or use a container platform that will do it for you. We don't really have any specific tool right now.
Any other question? If not, thank you again for your presentation.
Thank you for having me.
Thank you.
And we will wait a couple of minutes before receiving Clément.
Hello.
Hello Clément.
Ok. J'attends pour partager mon écran, j'imagine.
Oui, on t'entend là, tu stream.
Okay, I guess Clément, you can start your screen sharing.
And I was speaking being mute. I'll do it again. So our second speaker is Clément Oudot, who will show us how we can host identity access management service in the cloud with free software. Clément is contributor to many LDAP and IAM software and related free software, and is identity solution manager at Worktex. Yeah, floor is yours, Clément. Thank you.
Okay, thank you. Hope is good with a screen share. I think so.
Yes.
Yes.
Great. Thanks for attending this conference. Of course, it's an online conference, and I will be happy next year to share a drink with you to talk about several subjects. Of course, my favorite subject is identity and access management, and I will talk about that today. Some words about me. I work at Vortex. Vortex is a French company doing open source in infrastructure. And in my work, I contribute a lot to open source products like Lemon LDAP, LDAP Toolbox, LSC, Fusion IAM, and W Suite. And on my personal life, I'm doing music. Some of you may have heard some music of me last year. So the good news is that my music album was released this year. So you can listen to it on every platform, and you can get it on captain.org. So okay, it was my personal advertisement. Maybe you know that I like to do music, and I would like to introduce this subject, which is identity in the cloud, with a small song. So I hope you will enjoy it. Some people call me the LDAP cowboy. Some call me authentication man. Some people call me single sign-on guy, because I speak of identity in conference. Because I'm a hacker, a developer, I use servers and containers. I put identity in the cloud. I'm a hacker, software maker, open source community lover. My rock is weird for everyone. People talk about me, baby. Say I'm doing security wrong. Well, don't worry, baby, don't worry, cause I run service right here on localhost. Cause I'm a hacker, software maker, open source community lover. My work is here for everyone. I'm a hacker, a developer, I use servers and containers. I put identity in the cloud. I'm a hacker, a developer, I use servers and containers. I put identity in the cloud. Thank you. I hear some applause, so great. Now we can really talk about our subject, which is IAM. It is not the French song band, but this is identity and access management. So we split this between identity management and access management. Identity management concerns all that turned around the account, the identity of the user. So the life cycle of the user account from its creation to its deletion. We We work on provisioning in identity management, and of course, we try to provide to end users some services like how the user can edit its account or how the user can change its password. So all this is the identity management. Identity reconciliation is how we can get some information about user from several bases and to unify them in a single point of identity. And on the other side, you have the access management. It is how we give permission to users and how we apply these permissions. So it can be how we decide to put a user in a group and how we do to tell an application that only this group can access to the application. With access management, we also have all the audit. So we need to know which user has access to which application, so we can know what he is doing. So identity and access management are these two parts. And this scheme shows the identity life cycle. What is very important, of course, is account creation. So you have a new user in your own organization, and you need to have some tools to create the account of the user. And of course, you create its account and you give him some rights so he can use at least the mail server from the company, the wiki, some internal application. And you may be you may need to update his account to change some of his information, and of course to give him another permissions to access another application. So this is the second part of the identity life cycle. It's how you can edit the user account. And the last part is often a part that is missing in a lot of tools or processes. It's how we disable or how we delete the user account when the user leaves the organization. So here, the identity management should give an answer and should offer tools to clean the user account from the main identity server and also from all the applications. When we take a look to the identity and access management market, what we can see is that most of companies that are providing services around servicing on softwares around identity and access management are big American companies. You may know some of them. Of course, Oracle, Microsoft are big ones, but you have some companies specialized in identity and access management, like Ping Identity or Okta. And of course, there are very clever companies. The software are good, but they are often quite complex to administrate, and they are not free at all. So what about open source? Can we really have a full identity and access management in open source? The answer, I hope, is yes. It is my work to do this step, to have an identity and access management in open source. What I see is there is a lot of open source products already existing, but not covering all the identity and access management spectrum. So we may need to gather some of this product to have a full solution. So we created 2 years ago a new initiative which is called Fusion IAM, and we selected some open source components and try to bundle them so you have a full solution. All these components are free softwares, and there are not only community free software. We have 2 companies two two European companies between them, which is Vortex, my company, and Fusion Directory, which is the editor of the Fusion Directory component. I will present it just after. So we choose to bundle 5 open source products. One of them is really famous, is OpenLDAP. It's the main LDAP directory that is deployed in the world. And all of those components are LSC, LDAP Toolbox, Fusion Directory, and Lemon LDAP Engine. You may have noticed that I'm a contributor of some of them. Of course, this is why we chose them. Maybe you know OW2, which is a European consortium of open source and free softwares. Mainly all the components are registered in OW2, except OpenLDAP, which is a very wide world component, which is not in OW2, maybe not yet. All other components are OW2 projects. So what feature would we like to cover with Fusion IAM? I try to remove the name of the core components and to display them as a functional stacks. So you have on the left 2 web applications, which are the white pages and the service desk. I will present them just after. We have in the center the access manager, which is a component which will provide single sign-on and identity federation. You have the directory server, and you have on the right a synchronization connector and the directory manager. If we try to associate this functional component to software, you see that each component, it's one software, except for the directory server, because we use the OpenLDAP package from the LDAP Toolbox project. LDAP Toolbox takes the source code from OpenLDAP and add some tools for backup and monitoring, and provide a package for Debian and Red Hat with all these tools. So what is the directory server? So it is OpenLDAP. In this directory server, in this component, you will store your user and groups. You will have all the service accounts that are required for the other components to connect to the directory server. You will also configure the password policies in the directory server, and you will have the LDAP protocol. But the LDAP protocol, we choose to only open the LDAP protocol to the internal components. It means we don't publish the directory server to the outside. We'll see how the outside application can communicate with Fusion IAM. And as I said before, we have some useful scripts for backup, restore, monitoring, etc. The directory manager is one of the graphical part of the Fusion IAM. We have a web application that will allows any end user to edit some information that are stored inside the LDAP directory. There is no database here. All the information are inside the directory server, but the product will apply some access rules and authorization, so a user will only be able to edit the information that we configured. It is a very important point, because we will see just after that when we put this software in the cloud, we will want to isolate the data from the end user and from the customer, and isolate this data from the data, technical data owned by the hoster. And a very important point is that this component is providing a REST API. This REST API will be exposed in the cloud and will allow other tools to request and to provision some data inside the solution. The sync connector is just a small engine that will allow us to connect to any adapt directories or database in case you want to synchronize an existing directory to the solution. The access manager, maybe some of you know this screenshot. It's Lemonade.ng, and this is the single sign-on portal. It offers, when we put it in the cloud, we enable the SAML and then OpenID Connect protocols. It can use and provide second factors to users. There is a menu, password management, and very important, we have a centralized access control. It means that we can define some rules inside our identity and access management server. So any applications that we connect will be forced to respect these rules. It means, for example, with OpenID Connect, that your OpenID Connect response will not be forwarded to the application if the user has no access to the application. And the two last components, the first is white pages. It is just a small application that will allow the end user to browse the directory. You have a small screenshot when I try to create a directory with some Star Wars characters, and it displays photos and it displays all the useful information. You can think of a small intranet page where the user can get the information of the other collaborators in his organization. And you can do some data export in CSV or vCard. And the last one is the younger one. It was created last year, is Service Desk. It is aimed for level 1 support. It means when a user has issues to connect and to use its account, the support can go on this application and check if the password is correct, check if the account is locked, unlock the account, reset the password, etc., etc. The goal is to provide a very simple application for end user support and to not open all the directory to the support team. So this is all the features that we provide with Fusion IAM. And now this is the journey from installing Fusion IAM on my servers or on the customer servers, and how we try to create a software as a service product and to put identity in the cloud. The word to remember is IDaaS. IDaaS means identity as a service, and you already have today a lot of companies, mainly American ones, that are providing IDaaS. I talk about Okta, Ping Identity. These companies are providing their identity as a service. My goal is to have such software as a service, but only with open source components. So why I chose the cloud? I'm right here what I see as benefits and drawbacks. For me, benefits are that for the company, no installation, no infrastructure. So you only pay the hoster for you and you access to your identity. And of course, your availability and scalability is part of the work of the identity as a service provider. But the drawbacks, of course, are that the data is not hosted on your servers. It's hosted by another company. And you will have some difficulties to integrate it with your information system. There will be no issues if all your applications are recent applications and they are compatible with SAML or OpenID Connect, but this is not the case of all information systems and not the case of all applications. So using only cloud services may be not the solution if you have some old applications that you want to connect. And reversibility is an important point. You must read the contract, because if you want to leave your identity as a service provider, you want to get back your identities, your groups, your passwords. We also made a choice between isolation and multi-tenancy. So multi-tenancy is a picture on the right, and you see that we deploy one software and we configure the software to be able to answer to multiple companies. So there is a data isolation inside the software, and depending on which address is used by the end user, you will present one part of the software or one other. This requires a big server with the software, and of course, the benefit is that you only deploy one software and you configure it for each company. The isolation is another view. With the isolation, you will deploy as many software as companies. So the drawback is you need to deploy a software each time you have a new customer. But with the cloud, we will be able to easily deploy such softwares and configure. So we use Ansible to write all the commands that will build the image. And then we publish the image. And in the image, we also have Ansible script that will be run when the container starts. So Ansible is used to build the image and to run the image. We run the image. We will see here for the demonstration with Podman. Of course, our target platform for production is not Podman, it is OpenShift, which is the Kubernetes of Red Hat. We have the images registry on OW2 GitLab, but you can also use, of course, any registry. If you build your images, you can publish your images on any registry, including the OpenShift internal registry. We choose CentOS as operating system. So for the moment, all our containers are containers running on CentOS 8. And all the configuration settings are passed as environment variables, which is the common way to do with containers. So containers. Containers for me was really difficult to use, because I'm a quite old person, and I start by installing softwares on classical and bare metal servers. And when we told me that now to be in the top technical person, you need to do cloud and you need to do containers. So I tried to do that, and I faced a lot of issues. So some of issues are here. You need to define volumes for all persistent data. So if you don't want to lose your data, you must know which data are written by your process. You also need to expose on map ports, so you will be able to communicate with the container. You need most of the time to put all the required files in your image, else you will need to mount all the missing files as volume in your image to use them. And of course, the benefit of using containers is to be able to run several containers at the same time to do scalability. So you need to think when you create your image that several of this image can run in parallel. When you understand all of that, congratulations, because I just understand this today. A word of the data model. I said that we put this in the cloud and in an isolation model. So we will have only a directory server per company. But as we don't want that the company administrator access to all the data of the directory server, we isolate the data between the admin branch and the company branch. So the customer has its own branch with the user and groups and also password policies sub-branches, and the hoster, the administrator, it means you, if you deploy the software, you will be able to configure in another branch all the data that are needed to run the software. With the directory manager, you can then apply some rules. So the customer will not see any of your data. It will think that the only data in the directory server are the data from the company branch. So how we run that? The first thing to do is to create your configuration file with environment variant. So I listed some of them here. Of course, there are much more of this. You prepare your volumes. You will need to map your volumes, and you will be able to launch every image. So in the documentation, there are all the commands that are needed to run the image. When the image are started, you can start to create your user and groups and to connect applications. As you can see, we start all our images on a localhost, and we will share the network. We will be shared between containers only on the localhost interface, and we will just have a small reverse proxy in front of them, so we can expose our services to the external world. So this is the demo time. So I'll try to show you this. So all that you can see here is available in the Git repository in OW2. You will see that you have a build directory. It's all the scripts that are needed and the Docker files that are needed to create the images. But the images, I already published the images, so we can run directly the images without building them. If you need to adapt the containers, of course, you can rebuild all the images and use them when running it. So if you see the README, there are a lot of stuff. What you can see is there is some documentation on all the variables that you can use. So for the demonstration, I use this file, and I will create a server that will run for the domain demo.fusioniam.org, and it will run on my computer, because of course it works on my machine. All the other parameters are the accounts and the passwords, and I set here the company name. So this is the customer ID. So my directory branch will be called Acme. First, I run the directory. So we have some volumes here to store the data and the config. And they are mounted here. So we start first the directory. Okay, we see that we have a first container here. Next, we will start the white page component, which is the web interface that will be that allows us to browse the directory. It is split into two containers, one for the FastCG server and one for the Nginx server. So the two components are started here. And we will also start the Access Manager, the single sign-on portal. So you see that if you want to start it, you need to create some security keys for SAML protocol and OpenID Connect protocol, and also to create some volumes. The single sign-on software needs a database, so we use the standard Postgre container as a database. The database for the single sign-on component is only needed to store the configuration and the sessions. And then we will start the single sign-on server. So first, we start the FastCG server. And then we start here the Nginx server. There is a third container. You see that the same image is used, but we call it with another entry point. This one is just to run the session purge because we have a cron job. And of course, we cannot run cron job on containers like we run cron job on a physical or virtual server. So we start another container which will run the cron job. So if we list all the containers, you see that all of them are started. And I created on my laptop a small virtual host for my reverse proxy. So just to show you, it is very simple. So I declared here all the virtual hosts, and they are all directed to localhost 8080. Why? Because the 8080 port is the one from the Nginx server of the single sign-on server. The single sign-on server will receive all the network requests, and then will forward this request to the applications, to the protected applications. We can start a directory browser, an LDAP browser, to see what is inside the LDAP directory. Okay, so I'm connected to the directory, and you can see that I have my data model here. So this branch is a technical branch for the Fusion directory software. This one is my admin branch. So I created here some directory services account. I have some groups. All my security groups are here. So you can see I created super admin groups. I created some groups that are used for service accounts. So I can give some rights on the LDAP directory to service accounts by putting these accounts inside the security groups. And here we have some access group. So I configured, we will see that, I configured my single sign-on server to use these groups. So all this data are hidden to the end user and the customer, but the customer will start here and he has access to some users. So we can define users. I created just before the demonstration 3 sample users. And I have a group, which is a dynamic group, which will list all the users from my company. And I have also my password policy here. So we choose here that the company can adapt itself the password policy. Of course, it will be the company local administrator will be able to create new groups and new users. If we start logs, we can see, I will start logs for every component. And we'll see if the demonstration works. So I will connect to my local server. So my local server is started. We can see here, this is not a screenshot. I show you the logs. We are here on the containers. Here is my super admin account. So if I log with my super admin account, I will access to all components, including all the administration components. And if I go on the manager, I will see all the configuration of the LemonLDApp component. And you can see here, for example, for the web page, I have some access rules. Maybe I can show that in English, it's better. So you see here the access rules. So we choose to give access to all the access white page group, and here the access is to the Fusion directory group, etc., etc. And if I connect with an end user account, for example, Clark Kent. Clark Kent is the end user and can only access to the white page application. And if I put this in English, you can access to the gallery and you can check, for example, this page, and you see that I can access to Peter Parker information. This information are directly the information that are stored here in the directory. If I update this attribute, of course, my attribute is updated here. So we have all the logs here. We see that all is running here. Another feature that is directly provided, yes?
Clément, we're running a little bit out of time.
Okay. Okay. We have just 5 minutes for question, or it's over?
We can handle a question if there are questions, but
okay.
We are over, yeah.
Okay. Okay. It's okay for me. This is the end of the demonstration.
And thank you.
Thank you.
Is there any question on the Q&A?
course, the last maybe the last picture are the links if you want to use the product to contribute. Yeah, and we also have an IRC chat room on Libera.chat. Thank you. Thanks to the team, the organization team for this event. Good game.
Thanks to you again. Yeah.
Goodbye. I unsure maybe.
Yeah, so it's time to switch to the next next talk.
So Geoffroy, our next speaker is Geoffroy Coupry, who will present Biscuit, a new kind of authorization token made to be very flexible. Geoffroy does R&D and security at Clever Cloud. Hello, you can share your screen. We don't hear you.
We don't hear you. Maybe you're muted.
Is it okay now?
Yes.
Yeah. All right. Sorry.
No problem.
So yeah, I'm coming here to talk about Biscuit authorization tokens, a solution we've developed at Clever Cloud. So why is a web hosting company writing authorization tokens? We've had challenges around that, like how to integrate with bigger information system, enterprise customers, that kind of thing, how to make microservices communicate with each other, how to build multi-tenant systems, like giving a shared access to a cluster, that kind of thing. So we thought a bit about that problem and started looking at what can be done. And that's been one part of my work for the past 2 years. So I'm Geoffroy Coupry. I'm a Rust developer at Clever Cloud. I have mainly 3 areas of work. I work on the SOSU HTTP reverse proxy, that's built in Rust as well. The WebAssembly function as a service platform that we will release probably this year, and the Biscuit tokens. And personally, I'm the developer of the norm parser combinators library, also in Rust. That's been a foundational library in the Rust community to make formats. So when you want to look at authorization token, the first thing you see is the JSON web tokens. So it's a simple format. You take some JSON data and you sign it with public key cryptography. So RSA, DSA, there's also ECDSA, and you can also have private key signed signatures with HMAC. You can have encryption. It's very flexible. You can store whatever data you want. So claims about user ID, expiration date, a set of rights for user, session data, whatever you want. It's a container that you use, and you can send that in a cookie to the user. And when you get it back, you're sure it has not been tampered with. So you can store stuff in that. It's not. It's also been used a lot with OAuth and OIDC since it's a web standard now. So very well-known solution, very commonly used. A bit hard to implement properly. There have been a lot of vulnerabilities, always the same, but since it's so simple to write a JSON web token library, everybody makes the same mistakes. So the first one is, okay, you send the token to the server and say, I have a token and the signature algorithm is known. And the server says, okay. So you just send whatever and the server accepts it. There are some issues around the revocation because you cannot be completely stateless in your authorization. You have to store somewhere at least a list of tokens that you have to revoke, and it's traditionally been a challenge. So another solution that we've seen is the macaroons. So this is one I quite like. The design is very cool. The idea is that you have a token that's signed with private keys, a series of HMAC, and a macaroon is a list of caveats. A caveat is a condition over the request, something like, okay, the request can only come from this source IP, or here's the current time must be under this date, the resource we access must be this file and not another one. And the cool thing is it supports offline activations. That means you can take an existing token, you add a caveat, you add a restriction, and you get a new token, a new valid token that you can use with the same system without having talked to the origin server to add the restriction. You just take your token, add something, and you have a new restricted token that you can use. And the issue is that the caveat language is not defined. It's basically a byte array, so every user is defining their own language for that. So some variation of a text language. And to verify the token, you need a private key. The way it's designed is you have a root private key. You have the first caveat. You sign that with HMAC with the root private key as key. You get the signature, and what you send is the caveat and the signature. When you want to add a caveat, you sign the second caveat with the first signature, and you get a new signature, and then the new token is the first caveat, the second caveat, and the second signature. And if you receive a token and know the root key, you can just do the list of successive signing and verify that you get the same result in the end. So you must have the private key to verify. So it's not that flexible, but the idea of offline attenuation is very seducing. So what we ask is, could we get macaroons with public key cryptography? That would be a killer feature for the system. Like, we could separate the creator of the macaroon from the verifier. So the creator has the private key, the verifier has the public key, and you share a minimal list of you can isolate your security boundaries. You could also transmit a macaroon from service to service, attenuating the macaroon, and you don't need to share the key with everybody. You can just reduce, have the least possible right for request. And that's where we ended up with Biscuit. So a Biscuit token is a file that contains a chain of blocks. Each block is a public key and a list of rights or restrictions to the rights. So here we have an example idea of a token that has 3 blocks. So there was a token that was created with the root key and signed with the root key, and it has rights to read and write on folder 1, file 1, and only read on folder 2, file 1. And then someone took that token and attenuated that to another token that can now has the same rights but restrict to read. You can only read file. We cannot write any file. Okay, and this token has been further attenuated to a new one that say, okay, we can only affect files that start with /folder1. And so you can have a token that has a lot of rights at the beginning. You restrict it one by one, and then you still have a valid token, but with less and less rights. The verifier on its side, he knows the root public key. It says, okay, I have a request with the file /folder1/file1. I have a read operation. I have this token. I verify the checks. Okay, we have a check on read operation. It's all right. We have a check on /folder1. It's all right. We verify, because the verifier can have its own rule, verify that we have the right to read /folder1/file1. We have verified that it's coherent with the request, and then we validate the request. So this is the idea of Biscuit: is you take the attenuation from macaroons, you take the idea of adding checks on a request, and then you add some public key crypto on this. What can you do with that? So we've seen there are lots of use cases. We've seen two main ones that have been very interesting. The first one is around API authorization. So if you've played a lot with Auth, you've seen like it promises delegated authorization with one service getting a reduced access to another one. And so you can manage access to a service, delegate your authorization, but not too much to some other service. Like I want this photo service to give access to this printer service, and I don't want the printer service to access all of my pictures. Okay, so in reality, what happened is like most Auth providers, they have coarse-grained authorization. So you create a token here, it has too many rights, or you have the client, the consumer, that asks too many rights from the provider, and it makes also very complex right management interfaces. And it's been like we could do more, but at the same time, it's been hard, very, very hard to do it right. So a good example is when you try to get a GitHub token to your account for CI, for continuous integration. How can you make sure that the token cannot read or write to the wrong repository and reduce its right the way you want? So this is something that can be improved with Biscuit. The Auth provider cannot support all of the use cases. Like they may have some basic authorization mechanisms, some basic rules, but they cannot support all of the IDs that the consumers will ask for. So the idea is like you create a token and you let the user attenuate the tokens the way they want. The user can decide to have a shorter expression time, to limit the resource access, to limit the origins, that kind of thing. And it will be a contract between the provider to provide information needed for these policies, and the consumer, the client, the user, we can decide to restrict further the needs. So we have a great example at Clever Cloud. We providing a multi-tenant Apache Pulsar cluster. Apache Pulsar is it's a Kafka-like, so message queues, but with kind of better scalability and multi-tenant support. And the idea we wanted is like, okay, we can support multi-tenant access to the cluster, but we don't want to manually manage all of the tokens for all of the applications of our users. So the idea is that we give to a customer a Biscuit token with all the rights on their own namespace, so their own subset of the message queues that they can use. And then they can take that token and attenuate it, so each application can have reduced rights. So you can have an application that can only produce on one topic. There's an application that's meant as a pipe from one topic to another, and says, okay, it can only read from topic A and write to topic B, and only until this date. You can do that kind of thing. And the great idea there is that all of the rules we apply on who can do what, depending on the rights, depending on the token, applies, but then clients can add more restrictions, and it will be accessible for them. It will be validated as well. So this is very, very cool stuff. Like we deploy machines with very, very limited access that way. Another solution we've looked at is around microservice authorization. So if you've dabbled in that part, there are solutions around authorization between a series of microservices that need to talk to each other. And basically, there are three ways. The first one is each service has its own authorization system. So they must manually create a connection, create credentials to one another. And so it takes a lot of time to set that up. It fails very often because each one has a very specific authorization system. They can be in different languages, that kind of thing. And you end up with the confused APT problem, is that the authorization is not tied to the request that comes, it's tied to the service itself. So if you can trick a service to do more than the request should be able to do, the service will do that as well. The second way is to have a centralized authorization system. So you can have an API gateway, or one authorization service that everybody talks to, which is a single point of failure and adds a lot of overhead to your request. And the last solution is to use bearer tokens like JSON Web Tokens. And the thing is, when you start a request, and if the token is carried from a request from one service to the next, you cannot attenuate the token. You always have the full rights token. And a service could just keep one token and reuse it to do something else. It's not tied to the request itself. Well, it could if you mint the JSON Web Token specifically before that for this request, but it's still a pain to manage. With Biscuit, you can have the bearer token that's attenuated before being transmitted. So you can have a token that gives you access to everything. You can do whatever you want on the system, and then you attenuate that to a short-lived token. You limit the rights. You say, okay, I had the rights to invoice and look up inventory. No, I can only look up inventory. And each service, when talking to the next, reduces the right to only exactly what's needed and for the expiration span that's needed. So you can have very, very tight security, very well managed. And so here's a fictional example where there's a user that's slightly smiling and asks to order a product and uses their token with all of the rights for this user. The API gateway says, okay, I know this user, I know the product. So I start the request to the microservices and I tell the accounting service, okay, I have a command, an order for product 1. Here's a token from that user. It expires in 30 seconds. It can invoice this user. It can order a product if it's product 1. So the accounting service will look, okay, do we have enough money in that account? If I have enough money, I reduce the token and call the warehouse service to say, okay, I validate this order, so please order product 1. So here's a token with an expiration in 30 seconds, so it sometimes has passed. And the token can order the product if it's product 1. And the warehouse does not have much right. They can just check, okay, I have the product or not. If the product is there, I validate the order. And so from one service to the next, you can reduce the rights. And this is something you could not do with any other system until now, because JSON Web Token needs to have like a static token that's signed once and can attenuate. And macaroons require that all of the services know the private key if you want to attenuate from one to the other. And if all of them know the private key, all of them could mint any token. So it was not possible to do that. The only way you could do that before is with a centralized authorization system with all of the scalability issues that can come from there. So this is what you can do with Biscuit. So how does it work now? Biscuit is using public key cryptography with aggregated signatures. The idea is that you can take multiple messages signed with multiple keys, and you can just mix the signatures. And as long as you know the messages, the public keys, and the result signature, you can verify you can verify everything. And the idea is you can just add a new message with signature to the mix, and it will create a new valid signature. So it supports offline automation. The authorization language is based on Datalog. So Datalog is a subset of Polyglots. It's a logic language that we chose because it's very flexible. It's very easy to represent authorization policies with that language. Also, we can guarantee that it will terminate. If we can guarantee that the authorization program will halt, because there are only so much combination of facts and data. So there are lots of ways to store data, create data, and check for the authorization. And we worked also on some specific user experience parts, like how revocation should be done. Like if you have one token and you revoke that token, all of the tokens that were derived from that one should be revoked as well. So we had to specify how to work that. You can also extract the data from a verification if you want to audit that, if you want to test what happened, like, okay, I had this request with this data, I had this token, what happens, why did this request validate, or why did this one refuse? You can just retry, replay things like that. The cryptographic part, just for details, it's based on aggregated gamma signatures. It's an algorithm that comes from research around Bitcoin that was to reduce the size of blocks. It's implemented over the Ristretto group. Ristretto, it's a way to build a prime order group over elliptic curves. It's a great way to have a base system to implement crypto without mistakes. Like, you cannot have like a small group fixation, that kind of thing. Ristretto eliminates a lot of errors with that, and it can be implemented on Lipsodium. Lipsodium provides a Ristretto implementation, and I have example code somewhere if you want to build your own Biscuit implementation. On the serialization part, it's using protobuf. Each block is a protobuf structure that's signed, and we just add them after each other. So it's like that, like a Biscuit message is just a list of blocks with their keys and one signature. So let's get into Datalog, because this is the most interesting part, like the logic languages. So if you've not done any Datalog, the idea is that you work on relations between data. So a Datalog fact is data. Here we have the parent fact. You could see that as a table in a relational table. So we have the table parent with 2 columns. And so we have the relation between Alice and Bob. Alice is parent of Bob. Bob is parent of Charles. Charles is parent of Denise. We have rules that are used to create that data. So here we have a rule that say, okay, find a parent fact for which the second element is Charles, and return in the name variable, return me that name. So you can see that as a SQL request. So select distinct name from parent where child is Charles. And if we look at parent something Charles and look at the table we have Bob. Rules can be used to generate new facts as well. So to generate a grandparent fact, we find 2 parent facts with one in the middle that will match. So it's in SQL, it's a join. It's a way to build a join. The thing with Datalog compared to SQL is that joins are much easier to write, because it's the basic way to interrogate the data. And so here, if you look at the rule and the facts that we need, we have parent Alice Bob, parent Bob Charles, so we can generate the fact grandparent Alice Charles. We have parent Bob Charles, parent Charles Denise, we can generate the fact grandparent Bob Denise. So from that, we build checks. So the idea of checks is that it's how we do the condition, the caveats over the request. All of the checks must pass. All of the checks that are specified by a token must pass. All of the checks that are specified by the verifier must pass. And they work a bit like rule that you can do a query over data. So here we have one check that say, check if the operation is read. The ambient tag indicates that it's data pertaining to the request. We have another check there that says, okay, there must be a time fact that gives us the date, and this date must be before the 20th December of 2018. So I would just get outside. I would just show also the allow deny policies. While all of the checks must pass, an allow deny policy is there are a list of checks or a list of tests that are tried one after the other until one matches. So you must have one of those that will pass. So, and the allow deny policies can only be provided by the verifier. And here we have one that checks that if we have an operation and a resource, we must have a fact, a right fact for this resource and this operation. So I'll get outside the slide just 1 second to show the playground. So this is a WebAssembly-based solution that we wrote to test the Datalog language. Here on the left, we have one token with the first block. The authority block contains fact with the authority tag indicating the initial rights. So here we have a block that contains fact with rights to read /folder1/file1, to write /folder1/file1, to read /folder2/file1. And this, wait, I can just remove that. It's not that useful. And here we had a check that says, okay, is the operation read? And then we have another block that says, I want to restrict if I have a resource with a file path, the file path must start with /folder1. On the very first side, on the right, we have the data that corresponds to the request. So /folder1/file1 for the resource and read operation. And then we have the allow policy that will say, that says that we must check for the right. If I change the operation, then I have one rule that will fail, that I have one check that will fail, and the verifier will say, okay, it's this one, it's the check in block 1 and block 0, check 0, that say the operation must be read. Okay, so if I have that and say I change the path, then I have the operation read, I have /folder1, but then it does not pass the policy because I do not have the rights to /folder1/file2. I can say as an aparté that like all of this is done on the client side in WebAssembly. Every time I type a character, it's rebuilt by the WASM-based system that was written in Rust. So from there, let's go back to the presentation. So another example is the role-based access control. So since we still have 5 minutes, I will go back to that at the end if we have time. All right, but I can present a way to build that kind of thing. Here's the project status where we have right now. We have implementations in Rust, Java, Go, Haskell. And right now, someone is working on the C#. Swift has started. And so I'm waiting for the next implementation. So maybe Zig or something would be interesting. So if you'd like to look at that, contact me. I'd be happy to help. We have specification, lots of unit tests to help you write that. We have some real-world usage right now. So I talked about the Apache Pulsar authorization plugin that we developed. Someone told me that they're using Biscuit for the API authorization, but also as a license. So you have some content, contract or something that comes with a token. And the token specifies for how long you have access to the content, from which machine, that kind of thing. You can use that as a license. It's a very, very cool application for Biscuit. And a colleague of mine has been working on a layer for FoundationDB. FoundationDB is a key value data store that has been released in open source by Apple a while ago. The idea is it's kind of like a framework of database. You have a key value store with transactions, and you build the database you want over that. And we're making one where Biscuit is used to specify which key subset you have access to. So it's kind of interesting, and lots of more usages that you can find. And so if it gives you ideas, if you have something to ask, please come talk to me, because I'd be very, very happy to tell you more about it. All right. Here are the links, lots of them. There's a specification that's everything is open source. The specification has been developed in the open, and it's a very good place right now. We have the playground that I showed you. The main implementation right now, Rust, Java, and Go. And we published 2 articles in April So an introduction to how Biscuit, to what you can do with Biscuit, and another one that's a tutorial around Datalog. So if you're interested, you can start around there. Okay, so this is it. If you have any questions, I'd be happy to answer them. We can also go back to the playground and play with the role-based access control if you want, whatever you need. And I'm very happy to have presented here, and thank you to the organizer.
Thank you.
Are there any questions from the audience?
Well, I have a question.
Right.
If it can motivate others. I was wondering, when you started writing policies with Datalog, was there any kind of standard framework or standard language to express facts, or do you have to adapt it to well, basically, I mean, each time you integrate in a new server, you have to conceive the facts that will be needed for this server or application.
So
yeah, is there any standard in this, or
there's no standard for that right now. So Biscuit is a low-level building block. So you have to have a way to take your data from the database or something and put that in the token or in the verifier. We provide interfaces, APIs for that, but there's no like a standardized way to do Datalog for authorization. There are other projects that use a Datalog-like language. There's Open Policy Agent with their Rego language, and Ozo, which is doing a Datalog that's embedded in other languages and can query a data model from a web framework or that kind of thing. So there are lots of usage of Datalog in authorization, but nothing standard for now. No.
Yeah, I guess some kind of convergence here would be interesting, because being able to for a client to query the available facts and then to that could guide the writing of the rights that you want to enforce on these tokens. So I guess the publication service or something like that could be interesting. But there is I guess there is a lot of potential and a lot of work too. And I had another remark also. I guess when you try to integrate it in your software, I suppose there are two layers where you have to integrate it. First, you have the layer where you will decode and verify the Biscuit token. Mm-hmm. And then I guess it can be interesting to store the permissions in an underlying layer. I mean, for example, if you verify access to files, or if you verify access to data in a database, it can be interesting to encode in the engine the rights directly, so that you don't have to write them at another level.
Right. So this is possible actually. You can preload the verifier with some basic rules and data from your system, and then when you get a new request, you clone that verifier and apply the token and the request in there, and then so you always start from the right information. A challenge in that kind of system is querying the data for a user or something from the rest of the system, because it can create a lot of traffic. So you can have some preloaded way to check authorization. And we in the Pulsar token, in the Pulsar authorization plugin, we actually separate the part where we check the cryptographic part and the part where we check the authorization, because there's we authenticate the user at the connection, But then here on one connection that's multiplexed, the user can ask to look up one topic, produce to one, consume to another. So, and we have to check multiple times the authorization. So we verify the token, it stays in memory. And then on each new request, we can just keep the token and redo the authorization. So it's very flexible. We can do it. It's a building block. So find the right way to integrate that in your system. Yeah.
Yeah. Also, I guess if you can provide several scenarios or use cases for the integration in software, it can be easier to to convince software producers to integrate this new kind of tokens in their software. I guess that's yeah.
Yeah, we are at the point where we will try to integrate that in more software. A big target for me would be Keycloak. I really like that software because it's very, very flexible, very well designed. And I'd like to have a way for Keycloak to just create Biscuit tokens from authorization. That would be really cool.
Okay, thank you. No more questions from me.
Right. Any more questions? No, it's okay.
Seems so. Yep. Okay, so let's thank you again. And we will have a short break until the next presentation.
All right. Thank you.
Thank you. Bye.
Thank you.
shark attack, nom 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 nom, jellyfish, pan sandwich, turkey, snowman, dolphin, helicopter, last supper, monkey in a zoo. What? Gear shift.
Yo? Non, personne?
Ouais, salut. Hello, Ange.
Ça marche?
Salut Ange.
Ouais.
Oui, oui, on va rester muté jusqu'au début si tu veux bien.
Hello. We are really happy to introduce now Ange Albertini, who is going to speak about the manipulation of files and introduce the Mitre open source file mixer. So Ange, you can start to share your screen.
Share screen. Where is it? Share. Yes.
Perfect. You can start.
Wait. Okay, can you hear me correctly?
Yes.
Yes, absolutely.
Okay. Okay, so welcome to my talk. And my name is Ange Albertini. I will talk about generating weird files with Mitre. And I've been a hacker for some time, malware analyst and InfoSec engineers. And this talk is my own views and opinions. And this talk is no new exploits, nothing to be patched, just file format tricks. And we'll cover a few topics related to weird file formats. And let's start with the first. You have different depth of file parsing. You can just identify file types by just checking the magic, or you can go further at structure level and parse or validate the overall structure. And if you want to like render, print it, or anything, then you need to parse actually every element. And for each of these depth of parsing, you have different abuses. So you can add fake magics to full identification, or you can add fake structure elements to store either foreign payloads or foreign payload with a file type, so to create polyglots. And then you can go on and do things like hash collisions and near polyglots. And if you are abused at parser levels, like what happened yesterday with the VBR and MBR polyglots, is abuse parsers themselves. So you need, in this case, to know the difference between two parsers and create ambiguous files or file systems. So just clarification, it can be either just the magic or the full file format. If not, it's a polymorph or a mock or polymorph. And it can be one file format or several, and there could be some overlapping between the one single file or two files with some overlap. So in this case, it's either a polyglot or a near polyglot. And these are the abuse that I'm going to talk about. I mean, not all of them, but the abuse that I know about file formats. And I gave some talks on each of these topics. But today, this is what is covered by Mitre, and this is what I will discuss. Some more talks, the other ones I gave talks already, and nothing new in our case. Especially Mitre is a generic tool. That's very important. There can be a lot more abuses, but Mitre is a generic tool. That's the important point. So Mitre is just an open source software, MIT license, and it just takes two files as input. It tries very naively to identify the file types, and it tries with different combination and strategies to generate possible polyglots, and optionally, if you want, near polyglots. So you just run Mitre with a DCOM image and a PNG image, and it will, if everything works fine, it will generate a working polyglot, a DCOM PNG polyglot, for example. So it follows different strategies. The first and easiest strategy is just concatenation, which means abusing appended data more or less. So basically, when you have one file type that tolerates appended data, which is very common, and another file type that doesn't need to start at offset 0 and fits, starts the top file is small enough so that the second file is still valid. Usually it's just about copying data, but sometimes it requires some tweaking, like relocating the content of the file B. And at the step of concatenation, sometimes there are requirements of updates in the top file. Most of the time there aren't, but yeah, that's no big deal in general. And it's an old trick that still works and still bypass security and everything. So yeah, it's very simple. You can usually just concatenate two files blindly, but it still works and it can still be powerful. So my typical rant is that many polyglots would be prevented if formats were required to start at offset 0. And if in the next file format you design, or in your parser, you just enforce magics to be present at offset 0, it will save us a lot of headaches. Another strategy of polyglots and combination is just based on abusing cavities, so filling empty space. Basically, some file formats actually genuinely by default start with a lot of zeros, which is very interesting because sometimes you typically take, so for example, the 16 bytes of a file to identify its file types, and DCOM and ISO are two standard file formats. So if you don't know DCOM, it's what your doctor used basically. And it's the standard in medical environment. And DCOM starts by default with 128 bytes by courtesy, which is typically null or sometimes write a signature, but it's not relevant for file formats. It's just storage. And in the case of ISO image, it's 32 kilobytes of supposedly empty sectors. They can be used for in the case of hybrid ISO, but by standard, it could be zeros. And so basically you can just do what you want with this space, and you could put a file, and if it works and if it tolerates appended data, there you go. It's like concatenation, but with fixed offsets. So it's as simple as that. Again, it might require some adjustment, but typically it's just copying stuff. So word on polymorphs, now that we know how we can abuse some space, is that the idea of file type identification is that you require a specific magic at a given offset range, and the tool file that you know the command line standard tool is kind of typed by category in alphabetic order. So basically, it does acorn, it does console and then Windows at the end because W. That's how it works by alphabetic order. And in a real example, for example, this CV is a DCOM polyglot, and it's a Windows executable. It starts with MZ, but with file, it's identified as a DCOM medical image because image. So all the signatures contained are in image are scanned for M as DOS, even if the DOS magic is at offset 0 before the magic. So it's not by file order, it's by category order. And indeed, even if it was WannaCry, file would just say it's DCOM medical image. So it's simple bypass, but you can already see that it could create some big problem if your security is that fragile. So mock files is very trivial, right? Just put a mock magic at the right offset. But if it's good enough to bypass security, why bother, Of course, I went the extra mile and I created a bit extreme polymock. Like it contains no data at all. It just contains a lot of magics. So it's detected as 190 different file types by file with the keep going parameter or bin walk. And you can use that the source of that file as a reference with the magics to know which magic you should put at which offset to have which identification. And we'll see that later as an example, but you can very easily, also with the help of Mitre, make a MP4 being detected as Berkeley DB, like if you want. It's a very easy example. So my rant again, many mock files would be prevented if formats were required to start at offset 0. And again, enforce magics at offset 0. That's to make security simpler. So now a bit more complex strategy to combine file formats is to parasite one of the files, so basically abuse comments. And typically file format tolerates comments because it's normally not a problem. The only restriction is about their length, usually. Sometimes it's about that content, but usually it's not the problem. And then again, the same stuff about start offset of file B and whatever. But yeah, basically just you declare a comment and you put whatever data you want in it. So yeah, really like same song again, no problem, except that you need to make some room either in an official way with comment or not. Sometimes you abuse the file format. There is no command per se, but you can make some space in some way. So comments are a normal feature and they are very useful. Comments are usually just storing metadata like which software or what's the author or this kind of thing. And if it's a single or a few and a small and text commands, then it's good. But if there are many huge commands with very high entropy, then it can be very fishy. But on the other hand, comments are not considered critical. So they could be either removed or merged or scanned. So, if you want some filtering, you could also check the comments. But in general, in practice, they are typically just totally ignored, even if you put thousands of them in a file for abuse reasons. And for that, sometimes you need you can declare a comment or you can just force your way in the file. And then it depends on the structure of the file. So if your format is like a pure sequence, like it's a train, and if you want to add bogus information, bogus goods in a train, just add a wagon at the wagon boundary and update the wagons counter. If it's like an archive and it's like a set of stacked box, then just add your own box. You know, like you can imagine a real container ship, and you put a new container with some stuff inside. If it's pointers like a book, then you just add some pages somewhere and you update the table of contents so that the chapters are still properly indexed. And if it's like a chain of elements that are chaining each other, like towed boats, then just one of the rope longer and put some data between two boats, basically. So in the tricks that I've come across and that are sometimes implemented in Mitre, is that some formats have many different forms, like PDF and GIF notably, but not the only ones. And some forms are awful to abuse and some forms are much easier. So it's worth going the extra mile to make a generic software to find the right method to normalize all the input files to an abusable form. And then you abuse that form rather than having to handle everything. So basically you piggyback on an existing software or a trick to support all the files coming from that format. They will render the same way, but they will be much easier to hack and will save you a lot of time. So, which is why Mitre can stay very simple while being generic and working maybe with most files, most standard files. You know, it's a trade-off. Another trick that was also useful is let me guess with Limelight. Is it better? Maybe. Another trick that is useful is that some formats don't tolerate appended data. They're like, for example, there are few sequence of chunks until the end of file. And basically, if you append something, the typical parsers will reject the file because they couldn't parse some sequence. They just kept parsing everything. And in this case, the file will be rejected. So a trick is to wrap the appended data in a trailing chunk parasite. So it's just another kind of parasite, maybe. But for the second file, it's like being appended. Basically, you just declare a chunk with the right length so that the appended data that is coming next is still, how do you say, is still tolerated by the initial parser. So it's still a parasite, but for the second file, it's like if the second file doesn't tolerate appended data, then this file think it is appended data because there's no data further. And a combination of these strategies together is our zippers, which is mutual comments. So zippers like the thing you could have on your clothes right now. So each teeth is embracing the teeth of the other side. Each size is commenting out or parasitizing the other side. And basically, in a simpler way, the simplest ones are with a file format that starts out of Z0, but typically tolerates only a very small parasite, because otherwise you could just put the second file in it. And the first file needs to tolerate appended data. But then you see that each piece of the file will have a role for the other file. So one is the parasite, the head is on one side is the parasite of the other file, and so on. So the important part here is to overcome the limitations of the second file has a cavity or can start later, and the first file has a very small parasite. So basically, if file B is too big, and in the case of GIF, for example, a GIF command can only be 255 bytes. So it's very, very limiting. So instead, you will use this command, this parasite, to just host the head of the second file, so that the second file can declare a file type, and also a command to host the body of the initial file of the file A. So basically, you parasitize both sides, and then you merge the result. It can be very tricky. There's wrapping and everything, but in practice, it enables a lot of more combination. Again, with the files that have very small parasite, or don't tolerate appended data and so on. So yeah, the zippers are good for overcoming constraints. And all this in total gives the result of compatibility of Mitre. And again, there are more possible polyglots, but Mitre is generic, which is why, for example, PostScript and MP4 start at offset 0, but they don't enforce their magic at offset 0. So more polyglots are possible, but they cannot be done generically. So yeah, Mitre doesn't support that in a generic way, even though possible. Mitre, even though it would be possible. So Mitre supports many formats and tries all the combinations and the strategies. Okay, and it shows that each file format characteristic enables more possibilities, and it also shows that whenever you have formats enforcing magics at offset 0, the combination is not possible. So again, I reinforce my rant saying it will save the future security, make it simpler by preventing that to happen in further file formats. So under the hood, Mitre is probably much simpler than you think, because I really want it simple. And again, you don't have to fully understand a file format to abuse it. You just need to do the bare minimum, and Mitre is about doing the bare minimum. So just identify the overall structure, look for abusable characteristics, then just move blocks of data around. And optionally, you need to adjust some offsets and lengths or whatever, but that's all. And this is exactly what Mitre does, not more. It doesn't fully understand all formats. It expects standard files, and it doesn't validate the output files. It's not a full parser. It's not an analysis tool. Use at your own risk. And we'll just abuse JPEGs like Mitre does, the laziest possible way. JPEG is complex, and yet, well, let's look at the small JPEG, FFD8 and the JFIF, and And a JPEG file is a sequence of segments. They start with an FF, then with some marker, and optionally a length of 2 bytes. And if you just want to add to a parasite to a JPEG, you just need to insert a comment segment, so FFE, like file format forever, at offset 2. And you just write at offset 2 because this is the first boundary of segments, FFF2, then the length, and then the content of the parasite. And then you hosted some extra comment, some extra data, parasite data in your JPEG. And that's exactly what Mitre does. It doesn't know, that's a whole source file of JPEG support in Mitre. Just know the signature, just know the parasites are supported, where to cut the file, and how to wrap the parasite. That's all. So if you want to know more, check my POCs, my docs, and so on. That's really how smart Mitre is, no further. And let's see a look at the options of Mitre. So if you first want to embed any payload without a given file type, then just use the -f parameter to force it as a binary blob with no type. It's also useful if you just want to make some room in your file. And so, for example, if you take a JavaScript and, for example, a PNG, then you just use the -f parameter, and it will make a valid PNG with JavaScript payload that will be kept as is. And if with the right extension, it's a working JavaScript payload. Or you can use to create a polymock file. So, for example, you have an MP4 file, and you just create a small buffer containing the signature you want with padding. So you have to find it yourself, but it's not very complex. And then you just ask Mitre to say, hey, put this buffer inside the MP4 file, and our file will see that file, even though it's a working MP4 file, as a Berkeley DB file type. And basically, to generate a polyglot, there are not many options, except that the order of file arguments matters. So the first file will be on top. So you just have to know what you're doing, or just try the reverse argument to try both directions. And if you want to know, it will give you more information why a polyglot strategy will not work. Maybe the cavity space is too big, it's too small or something. Then just try the verbose flag argument. So now let's move on to near polyglots. The thing is, sometimes there are polyglots that are not possible because, for example, there's no PNG and BMP polyglot because both formats start at offset 0 with different signatures. So the overlapping of PNG and BMP prevents a polyglot. But so near polyglots are just kind of a weird workaround. I mean, it's not a workaround. It's just two files, non-working polyglots with the same body and just some overlapping data to be replaced. Of course, the smaller that data, the better, like just the magic. And the idea is to have an external operation that will swap the overlapping data. So it's, of course, not two totally different data. It's mostly, they are mostly the same, and you want to find a strategy to replace the overlapping data. So one of the idea is to do this replacement with a cryptographic operation. So instead of just copying a buffer somewhere, you just use encryption or decryption with specifically computed or brute force parameters like initialization vector or nonce to create what I call a crypto polyglot, which means the overlapping data will be replaced by this cryptographic operation. And you have the extra point that the other payload, when the clean payload is in clear, the malicious payload is encrypted, or I mean, it's not in clear. So it's quite powerful because it may look with this, like a standard file with appended data, but later it's actually a malicious file. So for example, here is a BMP PNG near polyglot with 16 bytes of overlap. So again, you can create that very easily with the extra overlap parameter in Mitre. And again, with the two versions of the 16 bytes buffer, it's either a valid BMP or a valid PNG. And with combining with one of the tools that you can find on the Mitre repository, which I use to call encryption, is that you can have this valid BMP. When you encrypt it with the proper initialization vector with standard AES-CBC, then it becomes the PNG that you wanted. So again, you abuse encryption by crafting some specific initialization vector, and the file, you control the input and the output more or less. Another example is with 3 bytes of overlap, you have a BMP and a postscript near polyglot. And here it's what's called time encryption. So basically you upload the BMP to a file storage, it encrypts the file, but if you know the key scheduling and rotation system, and then there's a new key that is, so the file is encrypted, is stored encrypted, and there are key rotation, new keys added to the key ring, but because it's authentically decrypted, it will just try every new key until there is decryption. And you can abuse that, you can brute force that so that the ciphertext will be decrypted authentically with different keys, and then it will give you the second file. So it was clean before, and when the new key appeared in the key ring, then it will be a different payload that you can plan. And again, this works in a generic way, so it could be this slide deck and WannaCry or whatever. You know, it's totally generic, and you can do that yourself with the tools in the Mitre repository. So to conclude on all this, Mitre is a simple weird file tool that is easy to extend with minimal file format knowledge. Mock files is very simple. It's about patching the right magic at the right offset, and you can use Mitre for that. It's trivial, but still good enough to bypass some security. Near polyglots might seem initially very weird, but they are very powerful when suddenly mixed with encryption operation. They don't apply just to CBC and GCM, but also with OCB3, GCM, SIV, and everything. Not everything, but yeah, I mean, all this. And if you want to know more, just look at the actual, the talk I gave before. And we actually we revised our paper, our academic paper on time encryption, officially called Authenticated Encryption Without Key Commitment, How to Abuse and Fix It. So this paper was revised last month. And this paper and also this slide deck are crypto polyglots. So right now I'm presenting with this the public slide deck, and using the software that you can extract from the file with 2 OpenSSL operations. So this is technically working because this is exactly what I'm doing right now. So this slide deck contains also a PDF viewer, which comes out from the same file with OpenSSL output. And again, maybe I didn't insist enough. One more thing, no more polyglots. Security should be simple. Type identification should be straightforward. enforce magics at offset 0 in your next file format, please, and in your parser if you can. And if you think it's something outdated, well, I found out that Nintendo Switch and NRO executable don't have their magic at offset 0. So if you think it's an idea of the past, you're wrong. Now, thanks for your attention. And if you have any questions, I'm all ears.
Thank you.
Thank you.
Thanks a lot. We have a fourth question. Can you read it, or do you want me to read you?
Oh, me?
You can click on Q&R on the bottom right on your Windows.
Two on what?
Okay, I'm going to read the question.
Q&A? No. Oh, nice present. Oh, okay, on question and answers. Okay.
Yeah.
Will you try? We try to add. So these questions, there are the two questions from Michael Ham, right?
Yeah, absolutely.
It's very easy to append a zip to file to regular file. Yeah, we used that for Porco GTFO long ago. So yes. Oh, so I have to type the answer. No, if they don't. So I click on first.
Up.
I click on first. Oh yeah, go ahead. Nice presentation. Will you try to add the merge of partition disk image? So if I'm answering live, right? I have very little knowledge of partition or file system for now because I was focused on file formats. But yes, I saw the talk and man, it seems like promising to look at file systems a bit further. So yeah, maybe next version of Mitre.
Okay, thanks. Does anybody have another question? I can ask you one. Is it possible to use file manipulation in order to avoid antiviruses detection or malware?
Yes, the most likely. I mean, they already know about the most standard ones, but usually, as you know, they have to be behind because otherwise the bad guys are idiots. But yes, there are already plenty of detections as soon as you have, for example, a P file with some HTML in the header, there will be some detection that triggered there. So you could just use that the other way around, but yes, it's definitely possible.
Okay, thank you. Does anybody have another question?
Here, Mitre handles two types of files. If you want to go further and see what are the possibilities for making a polyglot out of 3 file formats, is it something you want to handle in the future?
I don't see, so actually, I don't want to actually do that in, how do you say, because then generically it's very complex. Already some cases are really complex when there is data after the parasite in a chunk and there is wrap-any data. I mean, sometimes, and there are CRCs, sometimes it's already like you might want to run Z3 instead of Mitre, and Mitre wants to stay very simple. But yes, I kept some extreme examples. And this is one of my example of multi-polyglot. So it's a PDF executable HTML DCOM or ISO, APK, and Super Nintendo. And it's public. So it's just a demonstration that, yes, you can go further with polyglots, but Mitre is not going to be able to do that out of the loop because you have to really abuse different things together. And I just want this to be simple. But on the other hand, typically you don't want to go that way to have more than 2 because you just want to have one clean that bypass stuff and one malicious, right? And this is the other way around. You want to catch the bad one and not be fooled by the minimum, right? And typically bad guys want to fool you with the bare minimum. So you will not get further into exploitation, I think, with such a crazy file which I just, yeah, it was just an exercise of style, I'd say. And a rainy afternoon. Any more questions?
I don't think so. Okay, thanks again. Thanks a lot, Ange.
Okay.
Bye.
Thank you.
Thank you.
Sorry, there is one on the IRC.
Oh,
or
okay.
two even.
I
I'll
cannot
read
see
it
it.
out.
Can
So
you-
one question from Aklis. Would be Polyglot work with other identification tool like Fido or Siegfried?
I didn't try, but feel free to.
And
It
small
just
question.
depends if they are just identify file types or actually validating the structure or anything. But yeah, you know, in so many write-ups, I see people relying on file. It's like, okay, at least maybe I can show how easy it is to fool it by doing this. But yes, you can also trigger trick uncase with polyglots and ambiguous files. So in this case, it's much more serious. But I certainly didn't try and didn't have the time to try on all identification tools out there.
Another question from Virtual Labs. Have you ever considered using constraint solver Z3 or similar to create polyglots? And you mentioned it, I think, Z3.
Yeah, I didn't need to. Sometimes it's really difficult. I think sometimes for hash collisions, it was a bit difficult that you have one intermediate CRC at some point and then another one later, and they both cover the same buffer. It was tricky. But yeah, I mean, it can be. I don't think polyglots usually generic polyglots definitely are not worth it, but feel free to prove me wrong and do it. I will move on to something else. Most likely.
Thank you.
Okay, thank you.
Okay, thanks.
Okay, we'll have a small break
Of
till the next one.
almost 10 minutes until the next one. Welcome back. We are going to listen now Xavier Martin, who is going to talk about home-based block list in order to detect and block malicious activity in your network. So Xavier, you can start to share your presentation.
Okay, let me switch to full presentation. Okay, do you see my screen?
Yeah, we do.
Perfect. So let's go. First, thank you for accepting my presentation at this new edition of Pass the Salt. Yeah, it's my small contribution. I try to submit a talk every year, and usually it was successful. So I hope that you will enjoy it, and I will propose and present something which is interesting for a lot of people. This talk is called home-based distributed block lists. Why? The idea behind this call is just before looking for a specific product to manage block lists. I had the idea to do it by myself because when you don't find exactly the right tool, the right software, my philosophy is why not try to do it by yourself? So it's a good way to learn. It's a good way to practice new stuff, to learn new libraries and new technologies. So I decided to do something on my side. And I will explain you why, what are the motivation, and finally how the product works, and yeah, what you can try to do with it. So let's go. A few words about myself, just that's the classic slide. I will try to do it very quickly. So my name is Xavier Mertens. I'm based in Belgium. I'm freelance consultant. And beside my day job, so I have my own company, I'm also involved a lot with SANS. So it means that I'm a senior handler at the Internet Storm Center. So we try to generate a lot of content about what's happening on the internet. And these days, there are a lot of interesting / funny stuff happening on the internet, like Print Nightmare, the new ransomware. So a lot of companies being attacked in the US. So it's quite interesting. I'm also a SANS instructor for forensic malware analysis and reverse engineering. I'm co-organizer of the BruCon Security Conference. And also, of course, that's the goal of this conference. I like free software, and I'm really interested into integration and automation. Probably as many of you, I'm a lazy guy. So it means that when I find a way to automate my boring job and to do stuff automatically, I will try to do it. So I will spend some hours, sometimes I will spend some days, but at the end, I would like to do something working out of the box automatically so I don't have to do the dump and the monkey job. And based on this, I like a very specific software that I like to put in many projects is OSSEC. Probably if you attended some other conferences, I think I also did a workshop about OSSEC at a previous Pass the Salt conference. So it's really one of my key software. I really like it. Some facts. So the idea behind this talk, as I already said, the idea was to find something which is easy for me to deploy across my infrastructure. Today, what we have, so some facts, we have more and more application, more and more devices. We have to interconnect a lot of stuff, a lot of different architecture, and more. I don't like to use buzzwords, but we are switching slightly to the zero trust architecture. So it means that I have servers and application running at home. I have servers, application running on private servers hosted in data centers, but I also have applications running in the cloud. It could be Amazon, could be Google, and we need to make all those devices, all those application servers all together. And today, basically, the good old perimeter, like we know it for years. So it means, yeah, like the castle, and you have everything inside the castle. Everything which is outside the castle is by default malicious, suspicious, is bad. It's not the case today. So we are run open networks, and we need really to control everything. Also, we already had a lot of mention about Docker since the beginning of the conference. Today, your application is most of the time split across multiple microservices. So it means that if you have an application with a database, an API, a web server, something, or automation of script, you have all those different services working in Docker, so in a container, could be another technology, but in containers, and they have to talk together. So it means that you expose a bigger surface, and if you expose the surface attack, you are also more vulnerable to potential attacks. You need to control everything. And that's also why we need efficient tools to do our job. I'm a defender, basically, so I defend my customers. I also defend my own infrastructure, of course. So we need efficient tools to do this. And how can we protect ourselves? Let's try to block attackers, so simply. There are multiple ways to block malicious stuff. We can block, for example, based on suspicious locations. Honestly, I think the way to block based on suspicious location, I mean by suspicious location, I mean to block IP addresses of visitors coming from China, from Ukraine, Brazil, name your best country. I think it's completely irrelevant today because the attacker, they spread the different servers, the C2 servers, they spread the infrastructure across multiple locations, multiple countries, and you could have a C2 server located at an ISP in Belgium, so you will not be able to block this ISP. So based on geolocalization is totally irrelevant. We can also block the traffic based on suspicious activity, and that's what I like to do. I'm not blocking by default somebody, but if somebody is trying to do nasty activities against one of my servers, it will be blocked, thanks to OSSec, for example. And finally, to do this, the best way is still to use blacklist. Or today, yeah, I replaced black by blacklist because you know that today we see that more and more organizations, they tend to remove offensive words. So let's talk about blacklist instead of blacklist, but anyway, it's the same. So based on my idea how it should work, you have some activity detected from an IP address. Could be, once again, a brute force attack, a scan, could be any suspicious stuff. We verify if it's in the block list. If we have a match, we can drop it, we can block it, we can do a lot of interesting actions. For example, I'm running a tool where I just respond to an attack by another attack. When I mean another attack, it means that I scan automatically the offending IP address, which is interesting because sometimes I found very interesting servers hosted somewhere on the internet. So you scan me, you attack me, I will just scan you, I will check your footprint, and sometimes I discover very funny stuff. Otherwise, go ahead and you accept the connection, you accept the user, and everything runs fine. Blacklist / blocklist, very, very difficult to manage. Basically, everybody, I think, has a love and hate relationship with blocklist. It is my case. Honestly, I do. First, it's very easy to implement. You just have a bunch of IP addresses. You put them in a database, in a flat file, in a specific file format, and then you use it against against your tools, and you block people. But managing block list is a pain. Why? First, as I already mentioned, you can imagine it's not very effective because we have a lot of false positive. If you have a big server and this server is in the co-location, the server has a lot of virtual machines, virtual websites, and one of them is malicious. If you block this IP address, it means that you can, of course, affect your customers, your business, because you will prevent other completely legit services to run. Is it reliable? Yeah, we don't know. Where is this IP coming from? Why this IP address has been added in this block list? Why? What's the source? What's the reason? Since when? Is it for 3 months? Yesterday? 1 hour? A few minutes? We don't know. And finally, from a technical point of view, it's also difficult to manage. You have to sync them at regular interval. You have to keep them updated. You have to copy them across multiple devices, across multiple firewalls, whatever you want. So it's not very easy to manage. Also, block list, we have plenty of ways to find interesting block lists. Besides my own system, what I will describe in this presentation, we also have a lot of other tools that I'm also using. You see here 2 screenshots of my favorite tools. I presume that a lot of you recognize MISP. which is a very nice tool. So I have my own Lisp instance. I have also an instance of OpenCTI, Open Cyber Threat Intelligence. You can also find free feeds on the internet. So a lot of people, they compile list of domains, IP addresses, and they share them for free. Of course, at the opposite, you have a lot of companies trying to sell you a lot of feeds for a lot of money. And you have, that's very important, your local intelligence. What's happened on your site? What's happened in your infrastructure? What's happened related to your own business? That's why we are also facing the IOC problem. I like to mention this because a lot of people, they tend to say, yeah, I have a big database containing 50,000 IOCs, 50,000 domains, IP addresses, hashes, and so what? The size of your database with IOCs is, so an IOC is an indicator of compromise. Sorry for those that do not know this acronym. And for me, the most important is an IOC without the context has less or even no value. That's why I like the approach used in another product, which is called the Hive. The Hive is another very interesting tool to manage cases. So incident, it's a tool developed to manage incident handling cases. And the Hive has a very nice approach. Once you see an IP address, for example, for them, it's an observable. So you saw this in a log file, you saw this in a malware sample, you saw this in a log in somewhere. And then you have to apply the flag and to switch them to an IOC only if it's relevant for you, which is of course nice. Think about your business. If you are working for a bank, if you have an IP address used by a banking Trojan, this one is really priceless for you. But if you see a bunch of IOCs and those IOCs contain IP addresses which are used, for example, for, let's try to find example, denied of service or trying to target media companies, it's less relevant for you. And it doesn't mean that it's not important at all, but it's less relevant. The context is very important. So that's why I have to build my own block list. And I know that the IP address that I will put on this block list are really interesting for me because in my context, they are really relevant. And I prefer to have a list of 500 IP addresses. And I know that if I see one of them, it's very critical, I need to investigate immediately compared to a database with 50,000 or 100,000 IOC, but I don't have any idea about where they're coming from. So how can we populate this block list? Of course, you can have a lot of multiple information sources. You have your logs. You can, of course, collect, because I'm also collecting feeds and I'm trying to extract the most interesting information from them. You can also input them manually. Why not? From time to time, you read a report or you discuss with a colleague about a specific malware. Oh, I found an interesting sample. I found it tries to contact this IP addresses. So manually, you can add the information into the block list. But of course, the most powerful way to do it is to automate, because no monkey job. We have to know exactly what we do, and we have to do it in an efficient way. Automation. That's what I do. If I see activity from a suspicious IP address, I will try to add the IP address in this block list, and then I have two options. If the IP address, is already in the list, I will just add a citing to it. So it means that I will increment the counter. If it's not the case, I will just create a new entry. Why? It's a way for me to know if this IP address is seen multiple times. And an IP address that has been added, for example, 6 months ago, but I saw it only once, yeah, okay, could be interesting. But if I found, and if I added an IP address in the database 3 days ago, and the citing, so the number of hits is already 15, it's a good candidate to investigate, and this one must be definitively blocked. So it's another way to increase the value of an IP address for an observable. So let's switch now about the tool that I developed, that I'm using, and it's still in development. I started, of course, with some requirements. As I said, the ultimate goal was to automate something and to learn. I like to have fun, to spend hours. When I have an idea, I start to code. I'm not the best coder of the world. I found that my code is really shitty, but it works. And so the idea behind the project was to have something light. We already have a lot of tools that can manage blacklist. I mentioned MISP, for example. MISP is able to extract lists of interesting IP addresses, but MISP is a tool in this case which was quite big to manage. So I would like to start it for something which is very light, don't require a lot of resources, and of course, to access it, to read, write, to populate, and to create the tool, I need a REST API, because keep in mind that automation is mandatory. Of course, it should support multiple formats. So the information that you extract must be available, in my case, in JSON, XML, CSV. If I need to implement a new one, why not? It will be done very quickly. Easy to deploy, once again. So Docker to the rescue. So I'm running the service somewhere. If I need to deploy another one, for example, for a specific application, for a specific customer, I can just deploy a new container and it's done. And of course, as I said, to have a lot of fun and to learn new stuff. What about the architecture? The architecture is very simple. I have, in my Docker container, basically, what do I have? I have a Python script. This Python script uses multiple libraries, so it means that it builds the REST API. It has also a database which contains a very simple table with my data. And this REST API, I use them on the top of this slide. You see how I can feed the database using OSSec through the active response feature. I will mention this in a few minutes. I will give you a practical example. You can also feed it through the analyst. I have also a tool so I can, from my laptop, automatically add suspicious IP addresses and feed the database. And select your best tool. So you can, it's a REST API, so you can integrate it with any tool. And if you have another script which is able to find IP addresses, very easy to submit those data into the database. On the other side, so the bottom line, I have clients. So it means that those clients, they read and they fetch some information through the REST API to take actions. These actions could be blocking actions, like my PFSense firewall. So I have a bunch of firewalls located here and there, and all those firewalls have the same configuration and they share the same block list. So once one firewall at a location detected a suspicious IP address, automatically it will be locked by my OSSec. OSSec will trigger the active response. It will be stored in the database, and all the PFSense firewall automatically will be able to block the same IP address. Magic. You can also use it as a threat intel tool. I'm putting all my logs in threat intelligence, so in SIEM log management tool, and you can do correlation searches and detect alert, trigger alerts based on what you have in this database. And once again, question mark, because it's open to any kind of tool. How to deploy it? Deployment is quite simple because it's just a Docker. So I try to keep it very simple. And the Docker, you see, I will start on the left. You see the Docker compose. Basically, the only configuration step, the only configuration that you have to provide is the registration token that you see in red, because this token is mandatory to create new users. So before using the API, the tool, you have to create your account. And to create your account, you can self-provision your account by yourself, but you need to know the registration token. So super secret token. For the rest, it's a classic Docker compose file. And you see that what's in green, my API is just in front of a reverse proxy. So it means that I can have automatically HTTPS with a Let's Encrypt certificate, blah, blah, blah. Everything is fine. So my API is available. You see on the left, that's the Docker file. I'm just starting from a static Ubuntu, simple one. I install some dependency. You see it's very, very light. So I install SQLite 3, Python 3 pip. And I have a bunch of requirements. So it means that I install a lot of, well, I think I have 10, maximum 15 modules to build the API. And then I have some script. I create the database. I have classic stuff. My API.py is the main script, entry point, blah, blah, blah. So nothing really magic. And I have my Docker. So how does it work practically? The first step is to register a first user. Basically, the goal is to know which application added or an IP address. So very important for me. So it means that when you create a user, basically it could be a human, but most of my users are system accounts. It means that every time I connect a new application and this application must use read or write information into the database, I create a new set of credentials. So it means that based on this, I can track them and I can see which IP address has been created by this system, this application, this firewall, and so on. But basically, it's a classic API call. So you just submit a post request and you submit the data. It's up to, so the data you generate them by yourself. So at the moment, I don't generate the username. I don't have any specification regarding the password. So it's up to you to provide the password. Because some application, I had the case, very old application. I had some issue because the password, yeah, it's a very bad application. I will not name it, but it has a lot of constraint, and the password was maximum 10 characters, no specific characters, and so on. So I decided that the password has to be provided to the API. And finally, the result is your username. It means that it was successfully created. And in this case, that's the only way that's the only place where you have to specify the super secret token, because of course I don't want to have the API open to everybody. So that's what I implemented, a token to create your users. Once the user has been created, you will just use it to authenticate against the API. And then the first thing that you can do, of course, is to add an IP address. So in this case, you call the API using /IP/add, and the data that you pass, the two mandatory fields are the IP address, of course, but also a comment. I also implemented a comment because I would like to be able to track an IP address regarding something. This comment can be, for example, in my day-to-day usage, could be a case number. When I'm working on an incident, I just add the case number. Could be an OSSEC rule. Oh, there is a typo. I forgot the E. It could be an OSSEC rule. So I will know that this IP address has been detected by OSSEC and it is rule number blah, blah, blah. So I can track which IP address has been added in the database. Traceability for me is very important because in case of false positive, I must be sure to find who is the guilty guy, and that's this application, so I can probably try to refine my rule to fine-tune it to avoid false positive in the future. And once you added this IP, you have a nice message, IP address successfully saved. Woohoo! Of course, if you can add an IP, multiple IP addresses, you can query an IP. So it's the same. You query /IP/ and you give the IP address. By default, the return information will be in JSON. And you see this nice information. So it means that you have the comment, you have the citing, the source, when the IP address was added for the first time, when it was updated, what's the type. Right now, I'm just presenting only IP addresses, but I'm working on domains and other type of IOCs. So it means that you could also have some domains, username, hashes, whatever you want, and find the value. So you see here, the citing is 0, means that the IP address has been added, but it was never seen again. If tomorrow an application, a firewall will submit the same IP address, the citing will be incremented by 1, and of course, time updated will be changed to the correct timestamp. But of course, yeah, that's the example. If you had the same IP multiple times, you will see the citing increasing. In this case, I put a real example from my existing database. So 185.140.43 and so on is a malicious IP address because it has been already reported 11 times, so 10 times more after the first one it was reported. You see that it was reported in a very small amount in one day. The first time it was on the 15th June, and it was updated for the last time, the 16th. So in one day, approximately, I had 11 hits on this IP address. And this IP address was generated from my OSSEC. So OSSEC inserted by itself the IP address, and it was the alert ID 100.402. Piece of cake, very easy to understand. Of course, I need to automate stuff. Remember this, automation is key. So not all my tools are able to play with JSON. Yeah, JSON is nice, but sometimes you need to have something else. So by adding the parameter format, so if you query an IP address, but you put question mark format equals CSV, you will have exactly the same output, but in CSV. You can do the same in XML. You will get the same information in XML. Let's continue. You can also restrict the output. So instead of a lot of fields, you can specify which fields you would like to see. In this case, I'm interested only in the sightings. So you put question marks, fields equal sightings, and you will get only the sightings. The idea, of course, is to have something which is easy to parse, to generate more content to inject into another tool. And that's what I do, for example, with the next query. In this case, in this case, if you don't specify an IP address, but you specify the keyword all, and you combine with fields equal, I need the value and the format equal CSV, then you get only the list of all malicious IP addresses that you have in your database. And based on this, you can, I just displayed the last 10 ones, and then you have a file that you can inject in any tool. Very easy, very convenient. Well, I hope, but it works very smoothly for me. So you see that you can really extract interesting fields. You can extract multiple fields. If you put fields equals value colon comma sightings, you will get 2 columns in your CSV, so you can exactly extract what you want. The idea that I already have is to put also some conditions. For example, I would like to extract IP addresses that have a sighting above a specific value. So it could be also a way to reduce false positive and really extract very, very, very suspicious IP addresses. So now the integration with other tools. I will provide you 2 examples. The first one is how I can, using OSSEC, input some information into the database. Active response to the rescue. Active response is a very nice feature provided by OSSEC. What it does, it will just, you define some rules, and if a condition is met, it will trigger a script. And this script can do basically anything you want. And in this case, you see, so that's the first step, you define a new command, which is called API block, and my executable is API_block.py. That's the script that will receive the information from OSSEC and inject it into the API. What I expect in this case, I expect the source IP address. So OSSEC, when, for example, it detects an attack, it will take the source IP addresses, it will provide it to the API block.py, and the script will inject everything automatically. And it will inject everything with the OSSEC rule number and the correct user, the user is in the script. So I will have all the details, and I will be able to trace back where and when this IP address was added. Once you define the command, you just activate the active response. So that's the rule, the code block number 2. And you see here the very interesting line is rule group block IP. What does it mean? It means that every time a rule will belong to the rule group block IP, if it triggers, OSSEC will trigger the script. So based on all my rules, if I have 300 rules in my OSSEC configuration, I just have to tag them block IP, and automatically OSSEC will trigger the script. This is an example. On block 3, you have the rule 100.402. which means that I have, so the idea behind this, this rule is to detect multiple targeted login in a small period of time. And you have here the interesting login, which are John, Mike, admin, root. So what does it mean? If I have against a specific server a lot of faint login, that it means that I have in a time frame of 180 seconds, I have 10 invalid accounts. You see that the group block IP is added, so it will automatically trigger the script, and the source IP address, so the offending IP address, the IP address trying to do the brute force attack or trying to do some reconnaissance, will be blocked in the API. If it occurs on one server, automatically all the components that read and fetch IP addresses from this API will learn about this new IP, and it will be automatically blocked in another country, another firewall, another server, at a customer, and so on and so on. No, another type of input, because I said that a secret analyst can also add this to your database. So what I did, I have a small script on my MacBook, and when you see that this screenshot is a screenshot of the Hive, where I have an incident, so you see OSSEC multiple web server errors, blah blah blah. If you select an IP address, you highlight this IP address, you right-click with your mouse button, you apply service, and have an entry called blacklist IP. Based on this, I can put a comment or change the comment, and it will automatically add through the API this IP address that is selected, the 45.146 and so on. It will be added to the database. So from any software on my MacBook, I could be investigating a case, I could be in an application, in a PowerPoint, whatever you want, in a VM, right mouse button, select, highlight the IP, select blacklist IP, and boom, I automate the operation to the API. Nice. Now, the other way around, to integrate the output, let's have a look at PFSense. So PFSense is one of my favorite firewall because it's free, it works pretty well, it's reliable. I have plenty of them running. So PFSense has a very nice feature, which is dynamic aliases. So you can provide an URL, and from this URL, it will, at regular interval, it will fetch the URL, and it will generate dynamically the list of IP address or subnets or domain that you would like to block. That's the block, the number one. And block number two, you see that you define a rule in your firewall, and you say everything which is coming from the blacklist, or you see that I have several ones. I also have a blacklist coming from MISP. It will be blocked, and then I will have statistics, I will have information, it will be logged, and automatically the API will do the job and distribute the content across all the component, reading the different feeds. A quick overview to complete. So the development is still ongoing. What you can do now, you can post and you can create a new register. So remember, a user, you can create a new user, sorry. Remember that a user is something like a system account. So it's an application, it's a firewall that will feed the API. You can, of course, get the information about the user. You can get information about an IP address. You can get information about all the IP addresses. You can add an IP address. Of course, I did not mention this, but you can delete an IP address if you have a false positive or you see that something is weird. Or you can also say, for example, when an IP address has been added automatically 1 week after, 12 hours, 24 hours after, you can automatically delete it. And I have plenty of stuff in the pipe, so to add domains, users, to add more filters where you can, for example, as I said, extract only IP addresses with a citing above or less than this value, and so on and so on, or added after this time, before this timestamp, and so on. So basically just copy paste the functions that are already in place. So quick conclusion. First important, my goal was not to build a new MISP. As I said, MISP has already a lot of feature to do this. MISP can export list of IOCs and so on, but I would like to have something which is easy, which is simple, easy to deploy, does not use a lot of resources, and really custom made because the API does exactly what I want, no more, no less. And the core idea was also to share some stuff inside a network. What I do, I'm sharing, so the instance that I'm running here is only connected to internal stuff, my firewalls, threat intel platform, and so on. So the goal was not to exchange information with other instances like MISP does. MISP does a great job. I really like this tool, but it's not I would like to do something really simple. The code will be, of course, released soon on my GitHub account. Yes, I need to do some debugging cleanup and remove some junk code and so on. And of course, if you have some ideas, yeah, feel free to share with me, and I will be happy to integrate it, to answer your questions, to share some stuff with you. Yes, let's stay connected. So thank you very much. I'm just on time. It's perfect. So if you would like to contact me, you have my blog, my Twitter account, and my email address. Thank you very much. I don't know if there are some questions.
Thank you very much.
No, I don't see any question, but
Well, I just have one. I think that it looks quite similar to CrowdSec. Do you know this project? And can you tell us what are similarity and difference?
I don't know the project first, so I cannot reply. I cannot reply to this question. What are the different similarities? Once again, I'm sure that some people already coded the same kind of stuff on their side. Why I started from scratch? Because the idea for me was to learn. Basically, it's the first time that I implemented a REST API in Python. That was the idea behind this project. So I started from scratch. And yes, for sure, there are similar projects here and there, or probably GitHub is full of projects like this. Yeah, but I don't know the specific one. No, sorry.
Okay, I've put it on the chat.
Okay, I will have a look. I will have. Thank you.
Thank you so much.
Okay, you are welcome.
We just have 2 minutes before the last conference of the day. Hello. So now we have the last conference of the day. It's from Peter Kostasnik, and it's about security alerting using Python. So you can start your conference on share your screen. Thank you.
Thank you. Hi, can you hear me?
Yes, perfect.
Okay, perfect. I'm Peter Kostasnik, open source evangelist at One Identity, and today I will talk about security alerting made easy using Python. First, let me give you a quick overview of what I will be talking about today. First of all, I will try to define what is alerting. Then I will talk about two softwares I work every day. It's sudo and syslog-ng. And then show you how to do alerting the hard way using syslog-ng. And finally, I will introduce you to the Apprise Python library, which makes alerting a lot more easy, both for sudo and syslog-ng, and for many other software as well. So what is alerting? Alerting is a signal that warns of an attack or danger. In the real world, it can be an air raid or a chemical disaster. I have a similar loudspeaker close to my home and hear it on every first Monday of the month. It's pretty nasty. In the IT world, alerting is a message or a notification when something suspicious or important happens with your software. Traditionally, alerts were sent by email, but recently people expect rather Discord or Slack or many other online services for notifications. Let me talk a bit about sudo. Sudo allows a system administrator to delegate authority by giving certain users the ability to run some commands as root or another user by providing an audit trail of the commands and their arguments. It's a lot more than just a prefix, as most people consider it. Even the default configuration is quite useful. It's very basic. It gives all possible permissions to the members of the wheel group. But as long as you use sudo, you know who is doing what on your system from the log messages. And there are many other lesser known features of sudo. Here I want to mention session recording. You can record anything happening on the terminal and play it back like a movie. Originally, these recordings were saved locally and therefore easy to delete with unlimited access. But starting with sudo 1.9, central session recording became available, and this problem was solved. Another interesting possibility is LDAP for central management of sudo configuration. As this way, you can, if you change your, if you have many machines and change your configuration, then these changes propagate in real time. On the other hand, there are quite a few limitations of LDAP, so it's up to your environment if you want to use LDAP or a traditional configuration management system like Ansible or Puppet. Another new feature of Python, of sudo, is Python support, which we will use in my talk. This way, you can extend sudo not just by C-based plugin, but also using Python. It's using the very same API as the C-based plugins. On the other hand, there is no need for a dedicated development environment or compiling your software. My favorite here is the IOLogs API, which is using the very same API as session recording. So you can access any input and output from user sessions. and create, for example, a script which detects what is appearing on the screen and break a session if some important information is leaking. So you can think of it as data leak prevention, or you can analyze the command line and stop users from erasing your system. But the possibilities are endless. Here is a very simple example code. We define a class and within it a method log tty out, and here we check if my secret text appears in the buffer, and if it's there, then we before it could appear on the user's terminal, we break the session and print an error message on the screen. The other software I want to talk about is syslog-ng. It's an enhanced logging daemon with a strong focus on portability and high-performance central collection. Originally, it was developed in C, but you can extend it in Java and Python as well. So what is logging? It's a recording of events like an SSH login message, as you can see on the screen. Syslog-ng has 4 major roles. The first one is collecting data, like you can collect system and application logs together from a wide variety of platform-specific log sources, or as a central log server. Syslog-ng can use both the legacy and the new syslog protocol over UDP, TCP, and encrypted connections. It can also collect any kind of text data from applications, and as a wildcard, you can use also Python to create a log source. The next role is processing. You can classify, normalize, and structure log messages with built-in parsers. You can also rewrite log messages, and you don't have to think about falsifying log messages here, but for example, anonymization as required by different compliance regulations. You can also enrich log messages using syslog-ng, or reformat log messages using templates, as for example, Elasticsearch needs JSON formatting and so on. And you can also write parsers in Python, so you can implement any of the above features in Python, or you can enrich log messages from databases and also do filtering from Python, which leads us to our next topic. It's filtering data. It has 2 main uses. The first one is discarding surplus log messages, like not storing debug level messages. And it's also message routing, like making sure that authentication events reach your SIEM system. And for alerting, you also usually create quite complex filters to make sure that you receive alerts only on relevant events. And finally, you have to store your log messages somewhere. Traditionally, syslog messages were stored to text files, but now you can store messages to databases, big data, some NoSQL databases, message queuing, and using HTTP, you can connect to many different online services as well. And you can use Python and Java to write your destinations. We will use that for alerting here. A tricky question to wake you up before going on to alerting. What is common between the BMW and the Kindle? Both of these are running syslog-ng inside. So let's start talking about alerting again. Both sudo and syslog-ng support sending email alerts, but in the past couple of years, people started to use many other software for alerting. I mentioned Slack, Telegram, Discord, and so on. All of these can be reached using HTTP-based connections. The problem here that for any of these services, you need to read the extensive documentation, or in some cases, you need to reverse engineer the protocols themselves. And it can be painful and often not even possible to use these services using the HTTP destination. Let me show you an example. Alerting to Discord using the HTTP. It's relatively simple. For that, you need to read the Discord documentation. Based on that, create a webhook. Then go back to the Discord documentation and check out the curl example. And then also read the syslog-ng HTTP destination documentation. After reading through all of these pages, you are ready to create your Discord destination based on HTTP. You can use the blog below to check the steps how to do this. Here I show you the end result. It's the HTTP destination of syslog-ng. You need to define here a URL, method, user agent, the proper headers, and the properly formatted body to receive alerts in Discord. And what happens if your coworker asks for alerts on another service? You can start this whole process again and figure out how the given service works. Both sudo and syslog-ng support Python-based plugins. There are many Python libraries available on GitHub and elsewhere, which allow you to connect to different services. But it can be still difficult to implement alerting to all of these different services. Another very useful alternative is to use Apprise. It's a Python library on GitHub, which can send notifications to over 50 different online services, including the ones I already mentioned, like Slack, Telegram, but many others I have never heard about before. Let me show you a syslog-ng configuration implementing Apprise. I start with a network source. In a normal case, I would use a complex filter, but for testing, it's easier to use a network source and send messages there when I want to send messages to Discord, for example. And here you can see the definition of the Apprise destination. You see that it's a Python destination. That there is a we refer to a class name which implements the destination. We define the data which is sent to this destination, and also we configure the URL where we want to send our alerts. And at the bottom of the screen, you can see a log statement which connects the source and the destination together. Here you can see the Python code. It's embedded into the syslog-ng configuration. We import the Apprise Python library. Then we have the class as we had already in the syslog-ng configuration. Then we have an init method which initializes Apprise and configures the URL where we want to send the notifications. And here we have the method which actually sends the notifications using a price. As you can see, the data itself is hard-coded into the message what we send. We send the message macro of syslog-ng and the date macro. So it's not really flexible, but it works. We already solved that with this code, we don't have to rewrite our destination anymore for a new service, but just replace the URL, and we are ready to go to another use another service. But of course, there are many ways how we can improve our Python code and syslog-ng configuration. On the syslog-ng side, we can use blocks, which can hide away the implementation details. So it's easier for the end user, like the user doesn't have to know that it's based on Python, just write in the URL and is all set. And we can also use templates, which makes content of the message configurable and thus make our solution a lot more flexible. You can learn about these in the blog below. As we learned in the sudo overview, sudo also supports Python, starting with version 1.9. And for alerting, we can use the Audito API of Python, of sudo from Python. The problem here, what we need to resolve, that most services are throttled, which means that you can send only one message a second, or in some cases even less, which can slow down sudo quite considerable. On the following screens, I used an example code for the Audito API, and I modified it to send log messages using a price. And this slowdown needs to be worked on somehow. You can aggregate log messages. You can also send what is really important, or be just really patient and send log messages one by one. In my code, I combine these. So I implemented also both synchronous operation and also aggregating log messages. So the first batch of log messages are sent when a sudo session is approved, and the second one is sent at the end. This way, sudo is not slowed down too much. In the sample code, I marked with bold the price specific code. The rest is from the original Python code. In the init section, we initialize a price, configure the URL for alerting, and do a few more configurations like checking if we want to have synchronous operation or batching is okay. Here, the important part is here at the bottom of the screen. If the plugin type is sudo, that's the policy plugin of main policy plugin of sudo. If that's the one which is the last one to check if a session is allowed to run, we set a variable to true, so log messages are sent. And I commented out a line here which prints the environment variables, as in some services it's just too much and cannot be received by the service.
Peter, your time is supposed to be over. Do you have a lot of slides?
2 more screens,
okay,
if it's possible.
Perfect, thank you.
And here we send the notifications. The first few lines are for synchronous operations. So anytime any message arrives, then we send the notification. Otherwise, we send the first batch of log messages when the session is approved, and finally when the session is over. Here you can see a screenshot from Discord. As see the log messages sent by the price notification code. So let me summarize my talk. Alerting lets you act on interesting IT events, but recently email alerts are no more enough. Implementing online services one by one can be quite tiresome, but using Python support in sudo and syslog-ng can enhance your alerting possibilities quite a lot, especially if you start to use a price as it code once and send alerts to over 50 different services. And you can easily tailor a price to your own software easily as well. Thank you for your attention.
Thank you.
Thank you much, Peter. Does anybody have any question?
Yes, I have one question. Well, you said that directly alerting from sudo to a web service can slow down sudo. So would you recommend first logging into syslog-ng and then alerting from syslog-ng?
That's another possibility. So you can sudo logs everything to syslog-ng, and that way it's not blocking anything. But and you can use alerting from syslog-ng as well. But I was asked to how to implement alerting directly from sudo without any external applications. That's why I try to resolve it as well from sudo.
Okay. And well, then I don't know if you have done a lot of tests, but is it well, the slowdown on sudo, is it really important, or does it depend on how much you use sudo?
It depends on, for example, I have a setup where I have 4 different plugins approving a sudo session. And in that case, each plugin has its own log messages. And if you send those one by one, then you have to wait 5-6 seconds before your sudo command is executed. So that's why I aggregate everything before the main sudo plugin approves a session, and then it doesn't slow down anything.
Yeah.
Well,
okay.
Actually, there are 2 log messages, so there is a 1 second wait, but that's all.
Yeah, it's true that 5 seconds before your command is run can be quite frustrating, I guess.
Yes.
Okay, thank you.
Thank you.
Thank you.
Thanks.
Somebody has another question? Or we can finish for today? Okay, so thanks a lot, Peter. It was our last presentation for today. So see you tomorrow at 2 p.m.
Thank you.
Thank you.
To everyone who attended.
Bye.
Bye. See you tomorrow.